It's a PYQ session, and we will be discussing all the uh, previous year questions of ISI entrance, and the topic for this lecture will be integral calculus. Okay. So mostly, let me go through the basics first. Basics of integral, what is important over here, and what are we going to do? Mainly, the questions are asked from the properties and all. Okay. The questions, first of all, the questions are never asked from indefinite. Okay. You will be getting questions from indefinite. So indefinite wala concepts can be used to solve definite questions, but directly you won't be getting questions from indefinite integrals. Okay. Mainly the questions are asked from, few of the sections which are important for definite, from which you will find the questions are mostly from definite ka properties based questions. What are the categories of question? I'm just explaining those categories. Okay. The first is properties. Properties wala is very, very important. All sort of properties, especially inequalities. Inequalities of definite integrations. There are certain inequalities based properties, which is also very, very important for subjective paper. Properties ho gaya. Okay. And then sections like inequalities. So it's a part of this only. It's a part of this properties, you can call this. We teach this as a separate section, which is called the inequalities of definite integrals. ठीक है, inequalities हो गया. Then integration as a limit of a sum. Questions are also asked from this section. Integration as a limit of a sum. Integration as a limit of a sum is also, a topic which is from where you can get certain question. Now this is actually divided into two types. Integration as a limit of a sum is divided into two types. One is direct, like inequality based questions. Inequality based questions. एक तो ये हो गया. And the second type is basically Riemann sum based questions. Riemann sum based limit questions. Riemann sum based limit questions. Riemann sum based limit questions. Limits will be given. Limit is tending to infinity, and you have to convert that limit to integral, and then you have to solve. So those are basically Riemann sum based questions. These are the sections from which mostly the questions are asked from. Then the fourth one is being normally, see, the fourth one, I won't say the fourth one is a topic. Like fourth one is basically a tool. Fourth one is kind of a tool. ये जो tool है, माने tool of indefinite वाले जो सारे concepts है, all sort of indefinite वाले concepts like substitution, ठीक है, by parts, ठीक है, partial fractions and all those things which you learn in indefinite will be helpful to solve certain certain definite based questions as well. The tools of indefinite will be also helpful to solve definite based questions as well. Those are also very helpful. So these are the sections, these are the subtopics from which the questions are asked from in case of integral calculus. So I'll just explain this one. Okay. I'll just explain these two. More or less properties are known to you. Okay. Just roughly, I'm explaining these two topics. Roughly, I'm explaining these two topics, like what is inequalities. Okay. Inequalities, and we'll do some questions on integration as a limit of sums. Okay. We'll do a bit of theory and then we'll do some questions. So inequalities and integration as a limit of a sum. So I'm explaining this part first. I'm explaining this third wala first, and then I'll show you what are the inequalities which you need to take care of while solving the questions. So first, I'm starting off with this integration as a limit of a sum. So I'll just start with a very basic definition of this integration. So integration, in the sense, that what is the meaning of integration? Definite, basically. Now, whenever I'm saying integration, I mean to say definite integration over here. So what is the geometric meaning of definite integration? It represents the area under the curve. Any definite integral going in some finite range will definitely represent the area under the curve. Let's say I'm taking one curvature from this interval. In this interval A to B, I am taking a curvature. A to B. From A to B, I am taking a curvature. So what is the meaning of this integration A to B fx dx? This simply means the area of this curvature. Area under the curve. Area under the curve. This area is represented by integration A to B fx dx. So now what I'm going to do is I'll try to establish some sort of inequalities so that integration can be approximated in terms of summation. Okay. Integration can be approximated in terms of summation. In higher level physics, you will see that often you will find out that integration and summations can be exchanged sometimes to some extent, because both of them are kind of, approximates of each other. So kind of sometimes at the higher level, you will see that in physics and not in mathematics, we don't do these kind of blunders in mathematics, that we cannot just simply exchange integration and summation. So both of them are basically approximations of each other. So what I'm trying to do over here is I'll try to generate some sort of relations between integration and summation. Okay. So what will I do is basically I'll divide this region. Basically, we are taking from A to B. We are taking this area in this interval A to B. So what I'll try to do is I'll try to divide this particular region into small strips over here. I'll take small strips and try to divide this region. Okay. So I'll take the first strip over here. Likewise, here is the first strip. I'll try to divide this region into small strips over here. Like the first strip, I'm taking the strips over here. Okay, फिर second strip यहाँ पे आएगा, and so on so forth. Likewise, we'll have such many strips over here. The last strip will be somewhere over here. ठीक है. I am dividing this region into small strips by considering some small strips over here. This is x is equal to a. The first the first length over here is x. It starts from x is equal to a. Okay. And let us say I consider the width of this thing, I mean the breadth of this thing, to be h units. This is basically h units. ये जो width है ना, the width is considered to be h units. Okay. And what are these heights? Can we figure out these heights? Definitely yes. We have a. This is basically at x is equal to a. This is the height will be what? Function value will be what? F of a. Similarly, at x is equal to the next strip. What is the next strip? The next branch. The next branch will be a plus h, because the breadth has been taken to be h. ठीक है, ये जो gap है, this gap has been taken to be h. So a plus h, and then a plus 2h, and so on. कहाँ तक जाएगा? The last strip will be a plus nh. This will be starts from a, so the last strip will be a plus nh. And this one, this danda will be a plus n minus 1h. A plus n minus 1h. This is the thing. Okay. So these are all strips actually which I've taken over here. तो क्या करेंगे? Suppose for instance, for the first time when I'm taking this particular strip over here, let's say I'm taking this strip over here. ठीक है, यहाँ पे जोड़ दिया, यहाँ पे भी जोड़ दिया. I'm taking the strips in this sense. ठीक है. Likewise, suppose you keep on taking the strips in this way ना, ऐसे लेते हुए जाओगे, and so on so forth. ठीक है. So what I'm doing is I am just taking this much strip over here by taking a rectangle over here. This much rectangle I'm taking. यहाँ से I am taking this much rectangle. This much rectangle over here. ये total rectangle. समझ पा रहे हो ना? I am taking this much rectangle. I am taking this much rectangle over here. ठीक है. So once you figure out that this rectangle, once you just you take all of these rectangles over here. Similarly, the last वाला क्या होगा? Last वाला means this rectangle. This rectangle. This much I am taking. This much I am taking. This rectangle. Similarly, the last rectangle. So once you compile all of these areas, area क्या होगा यहाँ पे? What is the area of all these purple strips over here? ये जो purple strips है, what is the area of these purple strips? You all can figure out. ये तो rectangles है. So what can we say from here? This is basically the first one. The first strip is basically, the width is basically h, and height is what? F of a. Similarly, next वाले का height क्या होगा? ये height क्या होगा? What is this height? F of a plus h. फिर next वाले का height क्या होगा? F of a plus 2h, and so on. This will continue. ठीक है. तो if I compile all these areas over here, so we end up getting something like h times of f of a, length into breadth. Okay. What are these? Basically the areas of all these strips over here, all these purple strips over here. So f of h times of f of a plus h times of f of a plus h. Okay. Plus h times of f of a plus 2h, and so on. This will continue. This will continue till h times of, the last strip is basically, last strip क्या है? The last strip is h times of a plus n minus 1 times of h, है ना? ये वाला जो, ये तो height है ना? This height I am taking, this height. तो ये height कौन सा है? What is this height? This height is basically f of a plus n minus 1 times of h. समझ पा रहे हो कि नहीं? So a plus n minus 1 times of h. So this is actually the area. I just simply compiled all the areas of these purple strips over here, and we can write this as summation r is equal to 0 to n minus 1 times of summation r is equal to 0 to n minus 1 h times of f of a plus rh. We are writing this sum in terms of summation. So we are having summation r is equal to 0 to n minus 1 h times of f of a plus rh. देखो, so this is basically the area of all these purple strips over here. ठीक है? But these purple strips are not covering this entire region. These purple strips is not covering this entire region. ये थोड़ी ना पूरा region cover कर रहा है. So some regions are left out over here. See, some white regions are still left out over here. Once you just compile all these triangles over, sorry, all these strips over here, you will figure out that some of this white region, some of these areas are still left out over here. तो ये तो cover करना है. नहीं तो how can we say that this is integral fx dx? So to cover this thing, what I'm doing is I'm taking one more strips over here. So I'm overlapping some of the strips over here. So likewise, I'm taking some more strips over here. Likewise, ऐसे सोच लो, one few more strips I'm taking. थोड़ा ज्यादा value ले लेते हैं, ठीक है? ज्यादा value लेंगे. This strip I'm taking. Similarly, ये लेके यहाँ पे paste कर दो. पीछे वाले लेके यहाँ पे paste कर दो. Likewise, something I'm taking some more values basically. Logically, अगर सोचोगे, I'm taking some more values over here. ये लेके यहाँ paste कर दो. Means basically I'm taking extra values over here. Previously, we were getting purple strips over here. Now I am taking extra values. Extra values I am taking. माने now the strip is taken outside. समझ पा रहे हो ना? Now the strip is taken outside. ये जो green strips है, the green strips are basically exceeding this. मतलब ये ग्राफ के बाहर जा रहा है. So you are taking this extra strips over here. These green strips are, फिर से you start compiling all these green strips over here. ये आपको देखना है, आपको green strips ठीक से compile करना है. ठीक है? Again I'll try to compile the area of all these green strips over here. चलेगा? I'll try to compile the area of all these green strips over here. So what I do, compile करोगे तो ये तो ज्यादा आएगा. Basically, first of all, it's covering more area. You can see from here because this strip is taken in such a way कि ये बाहर चला गया curve के. This strip is taken in such a way कि ये curve के बाहर चला गया. ठीक है? Suppose if this is not visible from here because I have used two different colors over here, so you can see from here itself when I'm drawing a fresh graph. ये A है, ये B है. ठीक है? So this is basically you are having one strip like this, one strip is like this, second strip is like this. These strips are very small. These strips are very, very small. Likewise, I am taking the strips in this sense. A plus H, A plus 2H है. ठीक है? And so on. The last one is basically A plus NH. A plus NH. These strips are very, very small over here. Likewise. ठीक है? तो ये purple strips था. So now what I'm doing is I'm taking extra strips over here. Extra strips over here. ठीक है? Kind of. ये था purple strips. Now I am saying you take extra values over here. Extra area आप ले लो यहाँ से. Extra strips ले लो यहाँ से. Extra strip ले लो यहाँ से. Likewise. ठीक है? माने kind of what you are doing is you are kind of pasting the previous one. You are kind of taking and pasting the next one with the previous one. जैसे कि ये जो है ना, ये वाला, you are taking the next one, you are taking the next strip and you are pasting it over here. You are taking the next strip, ये वाला strip लिया और फिर यहाँ पे paste कर दिया. ठीक है? Similarly यहाँ पर भी एक strip आएगा, यहाँ पर भी एक strip आएगा. You are taking the next strip, ये वाला strip लेके यहाँ पे paste कर दिया. You are getting the next, take the next one and paste it over here. ठीक है? तो likewise you keep on doing the same and you will end up getting more areas over here. Likewise this will cover more areas. यही था green वाला strip. ये जो red color में जो दिखाई दे रहा है ये वाला, these are basically your more strips over here. ये ज्यादा values दे रहे हैं आपको. These strips are giving you more values. So hopefully the visualization is clear to you. ठीक है? So what I'll do next, I'll compile this. Similarly, just like this summation part, I'll compile this thing. तो compile अगर करोगे तो क्या आएगा? What I'm getting from here, this is basically it starts from, अभी देखो ज्यादा strips दे रहे हैं ना, we are taking more values. तो function value carefully अगर लिखोगे, ये function value क्या है यहाँ पे? Function value is basically f of a. This is f of a. ठीक है? This is f of a. This is f of a plus h. समझ पा रहे हो ना? ये f of a plus h है. This is f of a plus h. ठीक है? अच्छा, this is f of a plus 2h. तो देखो, what is the area of this green strip over here? What is the area of this particular strip? I mean to say this particular strip. What is the area of this particular strip? ये क्या होगा? What is the highest height? Breadth is the same, h. Breadth तो same है. Breadth is same. Breadth is basically h. तो h times of. लेकिन first strip का height क्या है? The height of the first strip is now a plus h. ये हाइट है, द हाइट ऑफ द फर्स्ट स्ट्रिप, अभी स्ट्रिप तो ये है ना, ये है ना फर्स्ट स्ट्रिप, सो व्हाट इज द फर्स्ट स्ट्रिप का हाइट, फर्स्ट स्ट्रिप का हाइट इज बेसिकली a plus h नाउ, f of a plus h नाउ, फर्स्ट स्ट्रिप का जो हाइट है, सी व्हाट यू हैव डन, बेसिकली यू हैव टेकन दिस स्ट्रिप, नेक्स्ट वाला लेके यहाँ पे पेस्ट करोगे ना, नेक्स्ट वाला लेके, नेक्स्ट वाला स्ट्रिप लेके यहाँ पे पेस्ट करोगे, सो व्हाट इज रिमेनिंग, व्हाट इज द हाइट ऑफ दिस स्ट्रिप, द हाइट ऑफ दिस स्ट्रिप विल बी f of a plus h, है कि नहीं, f of a plus h, समझ पा रहे हो ना व्हाट आई एम ट्राइंग टू से, ट्राई टू विजुअलाइज f of a plus h plus h times of f of a plus 2h, and so on, this will continue, and so on, this will continue till h times of f of a plus, कहां तक जाएगा, this will go up till f of a plus nh, लास्ट तक जाएगा, लास्ट तक जाएगा, because we are starting from 1, we are starting from 1, so f of a plus h, then f of a plus 2h, तो फाइनल में जाके फाइनल स्ट्रिप क्या होगा, the final strip is a plus nh, no, the final strip is what, a plus nh, तो ये जो हाइट है, ठीक है, ये जो हाइट आएगा, द फाइनल स्ट्रिप का हाइट क्या आएगा, फाइनल स्ट्रिप का हाइट आएगा a plus nh, ठीक है, ये जो फाइनल स्ट्रिप का जो हाइट आएगा, ये हाइट आएगा जो, ये क्या आएगा, f of a plus nh, ये वाला स्ट्रिप का, ये वाला स्ट्रिप का जो हाइट आएगा, ये वाला स्ट्रिप का जो हाइट आएगा, ये क्या आएगा, f of a plus nh, समझ पा रहे हो ना, because this function value is f of a plus nh. I hope this much is clear to you. So again, once you write down this thing in terms of summation, so summation r is equal to, कहां से स्टार्ट हो रहा है summation, summation is starting now from 1, summation r is equal to 1 to n, h times of f of a plus rh, h times of f of a plus rh, ठीक है. So basically we have calculated certain things over here. This is known as the Riemann lower sum. This is known as the Riemann lower sum, the one which is giving you the lesser area, the purple strip ka area. This is called the Riemann lower sum. This is called the Riemann lower sum, and this is called the Riemann upper sum. Riemann upper sum. ठीक है. When Riemann lower sum and Riemann upper sum are equal, then the function becomes integrable function. ठीक है. Anyway, so right now, what we are trying to do, we are trying to approximate this integral in terms of summation. So can I say this now? This region, this entire region, this region means integration a to b fx dx lies in between, integration a to b fx dx lies in between summation r is equal to 1 to n, because this one, this region, I mean this one, the Riemann upper sum will give you more area, because you are covering the green strips and the green strips are covering more area, क्योंकि वो तो बाहर जा रहा है ना, कर्व के बाहर जा रहा है, means this is covering more area. So this is the upper limit, which is h times of f of a plus rh, and the lower limit is what, lower limit. So we have established one inequality. The lower limit will be the Riemann lower sum, which is covering lesser area, the purple strips, r is equal to 0 to n minus 1, h times of f of a plus rh. This is covering lesser area. Clear? So next is, what are we trying to do from here is, we have established some sort of inequality. अभी ध्यान से देखना, next time taking this ratio, ठीक है, I will write this integral in terms of summation. When can I write this thing? ये case देखेंगे. So what I am doing is I am taking one ratio over here, which is b minus h divided by h. b minus a divided by h. I am taking this ratio b minus a divided by h, and I am taking this as n, let's say. This ratio, you name this ratio to be n. I call this is equal to n basically. So b minus a divided by h is one ratio which I am taking this to be n. ठीक है, चलेगा. तो ये क्या है? What is this actually? What is this? तो एक चीज यहां पे ध्यान से देखो. If what I am trying to do is, like I said, I am trying to approximate this integral in terms of summation. ठीक है. So while taking all these strips over here, once I am taking this purple strips over here, so which is giving you lesser area, and then second time I am taking the green strips over here, which is giving you more area. तो करे क्या? So what I'll try to do is I'll compile these strips over here in such a way, I'll take the strips as small as possible. माने the width है ना, width, I take h as small as possible. If I decrease the size of h, then what will happen? माने if I take the strips as thin as possible, ठीक है, तो you will see that slowly these strips will start compiling within this region. Yet slowly you will see that the strips will come under this region, means under this curve. Slowly the the strips will come under this curve. You all can visualize from here itself. I have given this diagram here. देखो, you take the strips as thin as possible. ठीक है, as thin as possible. ये strips तो बाहर था ना यहाँ पे. The strips were outside. ये बाहर था. ठीक है, you take the strips over here, all the strips over here, you try to take this strips as thin as possible. माने h को small कर दो, you reduce the width size को कम कर दो. So what will happen is basically these strips will start compiling within this region. They'll simply cover up this entire region. So what is the logic basically? Logic is ये जो strips है ना, h को small कर दो. H को small कर दो as h tends to 0. Now as h tends to 0, n will tend to infinity. Obvious reasons. As h tends to 0, n will tend to infinity. है ना? So what can I say from here? So this integration will be approximately equal to summation when integration a to b fx dx will be approximately equal to summation if limit n tends to infinity, summation r is equal to 0 to n minus 1. ठीक है, कोई सा भी ले लो. Summation r is equal to 0 to n minus 1. ये क्यों लिया? Can you see that we have used the sandwich theorem? We have used the sandwich theorem. ठीक है, this is independent of n. I have used the sandwich theorem over here. This is independent of n, right? So limit n tends to infinity. I take limits on all three sides. ठीक है, so by sandwich theorem, this must be equal to either the upper limit or the lower limit. कोई सा भी ले लो. 0 to n minus 1 ले लो कि ये वाला ले लो, 1 to n ले लो. Both have the same meaning. So 0 to n minus 1, h times of f of a plus rh follows from sandwich theorem. ठीक है, sandwich theorem से this follows. So this integration to be represented in terms of summation, you have to take n tends to infinity over here, and there. So we are getting some sort of relation over here. So here you can do a bit of conversion, like you will transfer this thing, limit n tends to infinity, summation r is equal to 0 to n minus 1. So let's keep this all in terms of n itself, like h is there. So we can find the value of h from here. What is h? B minus a divided by n. यही तो होगा ना h. So h is basically b minus a divided by n. ठीक है, and f of a plus rh, h माने b minus a divided by n, b minus a divided by n. So your integration a to b fx dx is limit n tends to infinity, summation r is equal to 0 to n minus 1, b minus a divided by n, f of a plus r times of b minus a divided by n. ठीक है, so this is your final version. Basically this is your integration a to b fx dx. This equals this actually. ठीक है, अब mainly we don't work out with this case. ठीक है, we don't remember or memorize this thing. ठीक है, what we remember is we remember the special case of this thing. We remember the special case of this thing, and based on this only we do the questions. वो special case क्या है? Just now we have proved integration a to b fx dx is limit n tends to infinity, this summation. ठीक है, तो वो special case क्या है? So we take a special case where if a is equal to 0 and b is equal to 1. We remember this special case. A is equal to 0, b is equal to 1. तो ये special case क्या है? यहीं पे replace कर दो integration, put the value of a and b to be 0 and 1 respectively. So a is 0. क्या हो जाएगा? This will become 0 to 1 fx dx. And this is equal to limit n tends to infinity. This will become summation r is equal to 0 to n minus 1. 0 to n minus 1. ठीक है, and 1, this will become 1 minus 0 by n, माने 1 by n. ठीक है, ये हो जाएगा 1 by n, and this will become f of a plus a 0, तो 0 plus r times of 1 minus 0 by n, माने r by n, तो f of r by n. यही पे अगर रिप्लेस करोगे, you will replace a 0 and b is 1, so you will have this summation to be fx is summation fx dx. Sorry, this integral 1 to 0 to 1 fx dx will be limit n tends to infinity, summation r is equal to 0 to n minus 1 by n times of f of r by n. And from here only you get lots of questions of limit. ठीक है, आपको लिमिट दिया जाएगा, you have to bring into this form, and you have to convert this into integral. ठीक है? So there is a process basically. ये process ध्यान रखना what we are supposed to do in case of such questions where you get limits and you have to solve using integration. So the first thing is you have to identify the form. You have to bring this 1 by n outside and you have to convert this function in terms of function of r by n. ठीक है? फिर जाके आप लोग ये कर सकते हो. You can replace this integration. माने क्या होगा ना, ये steps लिख लो. Steps for all questions. Steps for all questions. Steps for all limit questions. Limit questions. You can solve any limit questions using these steps actually. ठीक है? ये खाली ध्यान रखना. Any limit question, summation will be exchanged by integration. Summation will be, first of all, you have to identify the form. The first step is you need to, ये बोलेंगे नहीं, but you have to identify कि हाँ भाई ये limit question है and this limit question is solvable using integration as a limit of a sum. ठीक है? माने Riemann sum से. So summation is exchanged with integration. फिर क्या करोगे? 1 by n को रिप्लेस कर दोगे dx से. 1 by n को रिप्लेस कर दोगे dx से. ठीक है? फिर r by n को रिप्लेस कर दोगे x से. You will replace r by n by x. And the most important thing is you have to decide the upper limit and lower limit of this integral as well. So upper limit of this integral will be limit n tends to infinity. ये देख लो, process देख लो. For to decide the upper limit of integral, upper value of x, upper value of, sorry, r, upper value of r divided by n. And the lower limit will be, using this process you can solve any question. Lower value of r divided by n. So lower value of r मतलब ये summation का lower value. Summation का lower value. Lower value of r divided by n. Upper value of r divided by n and lower value of r divided by n. ठीक है? That is how you are supposed to solve. चलेगा? So basically the first thing is you need to identify that this is a question of Riemann sum. आपको लिमिट देख के समझना है. Some limit is given. Obvious reasons, limit will be n tends to infinity दिया जाएगा आपको. And see whether 1 by n is outside or not. ठीक है? And whether you can express this in terms of f of r by n or not. ठीक है? इस पे questions कुछ करवाएंगे. We'll do some PYQs of this form only. तो वही से clear हो जाएगा. ठीक है? अच्छा. So ये तो एक हो गया. Basically these are the steps for all limit questions. You will follow these steps and you can easily solve the questions. अच्छा. Coming down to these inequalities. Let me just quickly revise these inequalities. ये ज्यादा डिटेल में नहीं करवाएंगे. ठीक है? Just for the time being, you just need the application of all these inequalities over here. देखो, so what I've done is basically I've considered two numbers, two real numbers, a less than or equal to b, and we have considered fx and gx. These two functions are integrable on this interval. X belongs to a to b. ठीक है? तो देखो, first property is saying if fx is positive, ठीक है, I mean non-negative rather, more specifically it's non-negative. If fx is non-negative for all x lies in between a and b, then your integration a to b fx dx is also non-negative. That is also greater than or equal to 0. Obvious reasons, देखो fx is positive मतलब greater than or equal to 0. fx is positive है. कोई function जो है ना, any function is positive. तो ये अगर positive होता है तो in between a to b, ये भी तो positive ही होगा. What is integration fx dx? Integration a to b fx dx क्या होता है? Area under this curve. So that will be also positive. क्योंकि area ये तो positive है ना. Function is positive. So your integration, the area will be also positive. यही बोल रहा है. ठीक है? Very simple thing. तो देखो second वाला क्या बोल रहा है? Second one is saying fx is less than or equal to gx. fx is less than or equal to gx. ठीक है? Means we have two graphs. Now we are having two graphs. One is fx and the second one is gx. तो two graphs ले लो in such a way कि एक fx ले लो और एक gx ले लो. in this way. I am taking fx in this way. ये fx है और ये gx है. Two graphs I am taking, fx and gx. Obviously from the diagram itself you can clearly see fx is less than gx. यहाँ पे तो लेस देन है ना, इक्वल टू भी हो सकता है. ठीक है, fx is less than gx from here. You can clearly see from here. So अब बोल रहा है कि इंटीग्रेशन ऑफ fx will be also less than integration gx. Obvious reasons. देखो ये जो लोअर है, the region which will be traced out by fx, ये region, ये area, this area is given by integration of a to b fx dx. ठीक है, this blue region is given by integration a to b fx dx, and this purple region, ये जो total purple region है, is the area traced out by this gx in between a to b. समझ पा रहे हो ना? तो ये जो पर्पल रीजन है is obviously covering more area and the blue region is covering lesser area. यही तो बोल रहा है. ठीक है, कि ब्लू रीजन का एरिया इज लेसर देन पर्पल रीजन का एरिया. यही बस है. And the third one बोल रहा है कि third one is again very simple. So fx is having if there are constants m and m such that fx is lying in between small m and small m, capital M, sorry, for all x belongs to a to b, then integration of fx dx lies in between m times of b minus a and capital of m times of b minus a. ठीक है, तो ये क्या है भाई? You have a function which is having the minimum value small m and capital value capital M, maximum value capital M. ठीक है, minimum value is small m and maximum value is capital M. So I'll take such a function. एक function, ऐसा function ले लो ना. You take such a function whose minimum value is small m. ठीक है, minimum value is small m and maximum value is capital M. So I'm taking such a function in between this interval AB. Function is defined from here to here. ठीक है, तो fx are constant such that fx lies in between small m. माने ये जो height है, lowest height is basically small m. Lowest height is small m. तो ये जो है ना, ये lowest height है, ये lowest height है, ये lowest height of the function है. This is the lowest height of the function and this is the highest height of the function capital M. यही तो बोल रहा है. fx is lying in between small m and capital M. माने y, fx माने y. तो lowest height is basically small m. ये जो height है, ये small m है. This height is basically small m. Fine. And this height is capital M. This height is capital M. ये capital M है. ठीक है, क्या बोल रहा है भाई? तो if this configuration is true, then m times of b minus a, माने integration of a to b fx dx lies in between these two values, m times of b minus a and the highest value is capital of m times of b minus a. कैसे आ रहा है भाई, कैसे आ रहा है? तो इंटीग्रेशन क्या होगा? इंटीग्रेशन मतलब दिस एंटायर रीजन, इंटीग्रेशन मतलब दिस एंटायर रीजन. ठीक है, विच रीजन? दिस रीजन. लेट मी हाईलाइट दिस इज योर एंटायर रीजन. ये जो येलो रीजन है, दिस इज योर इंटीग्रेशन. दिस इज योर इंटीग्रेशन a to b fx dx. यही तो होता है. ठीक है, integration a to b fx dx. Now we figure out what is m times of b minus a. What is m times of b minus a? b minus a क्या है भाई? ये देखना है कि b minus a क्या है. This is 0 0. We are starting from 0. ठीक है, sorry, we are starting from 0. ये 0 है, तो how much is this gap? a. And how much is this complete gap? b. तो ये क्या है? b minus a. What is this? b minus a ना. ठीक है, अरे फ्रॉम b you subtract a, so you will be getting b minus a. यही तो है b minus a. ठीक है, चलेगा. अच्छा, तो now the thing is basically, so can you see that this much height, ये जो this much height है, this much height is basically your m. So your m times of b minus a is basically nothing but this rectangle, area of this rectangle, this black shaded one. So your m times of b minus a is nothing but the area of this black shaded rectangle. यही तो है m times of b minus a. This is only m times of b minus a. ठीक है, this will trace out a lower area. ठीक है। अच्छा, बाकी ये क्या है, बाकी कैपिटल ऑफ एम टाइम्स ऑफ बी माइनस ए क्या होगा, द एरिया ऑफ द बिगर रेक्टेंगल। कौन सा, ये रेक्टेंगल, दिस रेक्टेंगल, सोचो ये जो रेक्टेंगल होगा, दिस बिगर रेक्टेंगल, क्योंकि ये जो हाइट है, दिस मच हाइट इज बेसिकली योर कैपिटल एम, नो, दिस मच हाइट इज बेसिकली कैपिटल एम। सो डोंट यू थिंक दैट दिस टोटल रीजन, टोटल एरिया, ये जो होगा टोटल एरिया, ये जो टोटल एरिया होगा, दिस इज बेसिकली योर एम टाइम्स ऑफ बी माइनस ए, this is capital of m times of b minus a. Now compare. Now can you see from here that this yellow region will obviously be lying in between. ये जो है ना, this black shaded region, the नीचे वाला region will obviously trace out the lesser area. This will trace out the lesser area. ठीक है ना? This will trace out the lesser area. And this red region, total red region will trace out more area, क्योंकि ये तो कर्व के बाहर जा रहा है. This will trace out lesser area. ठीक है. So definitely this yellow region will lie in between this black shaded region and this red shaded region. यही चीज बोल रहा है बस. ठीक है. The black shaded region will give you m times of b minus a and the red shaded region will give you capital of m times of b minus a. चलेगा. और नेक्स्ट तो ये वाला है. नेक्स्ट तो दिस यू कैन वेरीफाई विद द हेल्प ऑफ एन एग्जांपल इटसेल्फ. ये तो आप लोग वैल्यूज लेके चेक कर सकते हो. ठीक है, कि mod of fx, mod of integration, and this is a very well known and important property I'm saying. This is a very well known property, important as well. So integration of a to b fx dx, the whole mod is always less than or equal to integration a to b mod of fx dx. You all can check by taking fx to be sin x. ठीक है. You all can check by taking some specific functions. You all can verify this thing. तो ये आप लोग ट्राई करना प्रूफ. ठीक है. fx, take fx to be sin x in some specific interval. Let's say आप लोग 0 to pi by 2 ले लो या फिर 0 to pi ले लो. तो you will verify that integration mod of integration, ठीक है, 0 to, you take some more values, let's say 5 pi by 2 or something. ठीक है. sin x dx, this is always less than or equal to integration 0 to 1, 0 to 5 pi by 2 mod of sin x dx. ठीक है. This also graphically you all can figure out. You all can figure out by taking some values over here, but you need the proof of this thing. And similarly the Cauchy squares. देखो ये ज्यादा यूज नहीं होता है. This is not widely used. ठीक है. Cauchy squares तो you people have done in inequalities. When you learn algebraic inequalities, you learn Cauchy squares inequality. So this is Cauchy squares for integration. This is Cauchy squares inequalities for integrals. Integration of a to b fx into gx dx. The product of two functions is taken. ठीक है. अब ये ज्यादा यूज नहीं होता है. This is rarely, very rarely used. ठीक है, लेकिन हो सकता है कि काम में लग जाए. But do remember this thing. So we have integration a to b fx dx, fx into gx into dx का whole square is less than or equal to integral of a to b f square x dx, माने f square x माने fx whole square. ठीक है. this simply means fx whole square. ठीक है. Times of integration of a to b g square x dx. So you all can compare with this Cauchy squares inequality of algebra. ठीक है. Both have the similar look. So we move on to the questions next. A lot of inequalities we have done. Hopefully this much is clear to you. ठीक है. चलेगा ना. चलो questions. So we start off with the 2024 PYQs first, and then धीरे-धीरे we'll slowly do. चलो first question. These are all PYQs of integral calculus. देखो फर्स्ट क्वेश्चन क्या बोल रहा है. फाइंड द लिमिट n टेंड्स टू इंफिनिटी 2 log 2 plus 3 log 3 and so on till n log n divided by n square log. ठीक है. This is one such questions where students have wasted a lot of time while trying to express this in terms of f of r by n. ठीक है. वो बोला था ना लिमिट n टेंड्स टू इंफिनिटी और फिर समेशन दिया जाएगा. ठीक है. You have to see whether 1 by n is there or not. It's difficult to be represented in terms of f of r by n. ठीक है. Whenever you see such kind of limits questions are given, limit is n tending to infinity and a continued series is given. So first what you do is you try to write this in terms of summation first. ये क्या है? Summation n tends to infinity 2 log 2 3 log 3 and so on till n log n. मैंने summation आप ले लो 2 से ले लो, r is equal to 2 to n and this is basically r log r और नीचे n square log n. N square log n is there. So this is one problem is you will get 1 by n. यहाँ पे 1 by n एक बाहर है, r by n भी है, but log r by log n is there. You cannot convert this easily in terms of n, function of r by n. ठीक है, तो ये रीमान सम का क्वेश्चन तो है नहीं, डायरेक्ट रीमान सम का है नहीं, मतलब रीमान सम का ये बेसिकली वी हैव टू सॉल्व दिस वाज वन ऑफ द डिफिकल्ट क्वेश्चंस. तो ये जो चीज है basically limit n tends to infinity. See how they are giving questions from the basic definitions, means integration as a limit of a sums, which students actually kind of ignore while doing their preparations. So limit n tends to infinity, खुद ही सोचो. See over here, limit n tends to infinity, ये है ना, यहाँ पे r is equal to some summation is there, ठीक है, ये r by n है, this is r by n, fine. Then we are having 1 by n. 1 by n भी बाहर है. 1 by n is also there. Summation is dependent on r. So 1 by n is a constant with respect to this summation. ठीक है, तो 1 by n भी बाहर है, no problem. फिर log r by log n is there. Log r by log n. So this cannot be converted in terms of Riemann sum. You cannot express this into integration of something fx dx. ये हो नहीं सकता. Not possible, right? This is the main thing. So log r by log n is not the same as log of r by n. तो ये चीज तो गलत है. So lots of students have tried to express this. It's possible with some, with some forceful manipulation हो सकता है कि हो भी जाए, ठीक है. But what is the actual way of solving this thing? Again, I'm saying with forceful manipulation, this is possible. You can bring into a function of r by n form and then work out with this thing. But those are kind of forceful manipulations. Those are forceful manipulations. आप बोलोगे सर यहाँ पे ऐड कर देते, basically I can add, not add, basically subtract, log of n कर देते हैं, फिर प्लस कर देते, प्लस log of n कर देते, ठीक है. So log of, what will happen? You will be getting log of r by n, r minus n, log of r minus log of n, which is log of r by n, ऊपर आ जाएगा log of n, ठीक है, and divided by नीचे similarly log of n, and plus log of n divided by log of n, which is 1. यही चीज आएगा. मैक्स टू मैक्स यू ऑल कैन डू दिस थिंग. आप बोलोगे ये चीज, बट दीज आर यू आर फोर्सिंग योरसेल्व्स टू गिव द आंसर. यू आर फोर्सिंग योरसेल्व्स. दिस इज नॉट द वे, ठीक है. हो सकता है कि ये हो भी जाए और लास्ट में जाके कॉन्फ्लिक्ट आ जाएगा. लास्ट में यू विल बी फेसिंग अ कॉन्फ्लिक्ट, ठीक है. ये हो भी जाएगा. लाइक वन ऑफ माई, आई रिमेंबर दिस थिंग, लाइक वन ऑफ माई स्टूडेंट हैव एक्चुअली डिड सॉल्व दिस थिंग यूजिंग दिस मेथड, ठीक है. तो वो लास्ट में जाके एक कॉन्फ्लिक्ट आ रहा है, लेकिन वो लास्ट में एक कॉन्फ्लिक्ट आएगा which is actually kind of not, वो लिमिट्स का एक कॉन्फ्लिक्ट आएगा. So you all can try with this method, but I am showing you this actual way how to solve this particular question, ठीक है. तो आ जा. So what I'll do is, so our concerned function, just I'll take one function over here. देखो, I'll take one function over here because our concerned summation is summation r is equal to 2 to n r times of log r. So what I'm doing is I'm just taking one function over here which we'll study, ठीक है. ये क्यों फंक्शन क्यों लेंगे? I'm taking this function as x log x. क्यों फंक्शन लेंगे यहाँ पे x log x? Because we need to see whether we just need to see the rough sketch of this thing. We just need to see the rough sketch of this particular function, ठीक है. ये फंक्शन रफ स्केच क्यों चाहिए? पता है क्यों चाहिए? Because the previous case we have solved, when we have established this inequality over here, we have taken this function in the increasing form. ये अगर increasing form में होता है, so this inequality will hold. Now what if the graph is taken in decreasing form? तो same चीज आएगा, then this orientation of this inequality will change. So for decreasing functions, this orientation will change. So what we need to do is we need to check the behavior over here. We need to check the behavior, ठीक है, behavior of this function. तो fx is x log x. f dash of x करोगे क्या आएगा? x into log x, which is 1 by x, और फिर log x times of x का differentiation 1. तो ये क्या आ जाएगा? 1 by log x. Now 1 by log x over here is, as x is positive, x positive है यहाँ पे, क्योंकि log x का डोमेन क्या है? पॉजिटिव है. Also you can figure out here, I have taken x log x, यहाँ पे r log r है, r is going from 2 to n, तो r तो यहाँ पे पॉजिटिव ही है. r is definitely more than 1, ठीक है. 1 या means 1 या फिर 1 से ज्यादा, तो greater r is definitely, so x is greater than or equal to 1 over here. So our concerned values are positive. तो यहाँ पे ये x भी पॉजिटिव ही होगा. सो फॉर पॉजिटिव x 1 प्लस लॉग x इज ऑल्सो पॉजिटिव. ठीक है, क्योंकि 1 प्लस लॉग x पॉजिटिव है, माने f डैश ऑफ x इज ग्रेटर देन 0, विच मीन्स f इज इंक्रीजिंग फंक्शन. f is increasing. F dash of x is greater than 0, which means f is increasing function. So now we know the rough sketch of this graph. The graph is increasing over here, so the graph will be somewhat like this. ये होगा ग्राफ. क्लियर है? तो ये होगा ग्राफ. ठीक है, तो फिर वही स्ट्रिप वाला लॉजिक. So basically I'm taking the strips from, it's starting from 2, so I'm starting from 2 also. You all can start from 1 also. ये mandatory है नहीं कि you have to start the strip from 2 itself. You can start from 1 itself. 1 से भी start हो सकता है. ठीक है, क्योंकि ये जो है ना 1 log 1 is 0 basically. That's why they have started from 2 log 2. तो you can start from 1 log 1 as well. तो I'm starting from 2. तो ये 2. ठीक है, फिर next क्या होगा? Next is 3 and 4 and so on. यही तो होता है बेसिक मीनिंग समेशन का बेसिक मीनिंग. सो बेसिकली आई एम टेकिंग ऑल द स्ट्रिप्स ओवर हियर एंड सो ऑन. ठीक है, ये कहां तक जाएगा? दिस विल गो अप टू द लास्ट स्ट्रिप विल बी n+1. वो 1 से स्टार्ट होता है तो n तक जाएगा. ये 2 से स्टार्ट हो रहा है n+1. द लास्ट स्ट्रिप विल बी n+1. ठीक है, एंड दिस डंडा, दिस वन विल बी n, दिस वन विल बी n. ठीक है, तो वो सेकेंड लास्ट वाला n होगा. फिर तो वही स्ट्रिप वाला लॉजिक. ठीक है, हमने क्या किया था? फर्स्ट वी हैव टेकन द पर्पल स्ट्रिप्स ओवर हियर. ठीक है, which will you know trace out the lesser area. This will trace out the lesser area. This traces out lesser area. समझ पा रहे हो ना? This traces out lesser area. ये पर्पल स्ट्रिप्स जो है ना, this will trace out lesser area. क्लियर है? This is tracing out lesser area. अच्छा, so what can I say from here? So your integration, your summation, यहाँ पे तो summation है. देखो यहाँ पे उल्टा है एक्चुअली. यहाँ पे आपको उल्टा चीज करना है. You have to do the opposite thing. Previously we had represented integration in terms of summation. Now you have to represent summation in terms of integration. Logic same रहेगा. Logic remains the same. ठीक है, you have to represent summation in terms of integration. Like I said, both can be exchanged. Sometimes both are basically interrelated. मतलब क्या है कि those are approximate values of each other. So inequalities में summation, sometimes summation and integration can be exchanged. So kind of you can say those are, you know, those are basically approximate values of each other. Approximate values है. So r is going from 2 to n. यही तो है ना summation. We have to approximate this thing. तो ये जो सारे पर्पल ये होगा मीन्स स्ट्रिप्स होगा ना. सो द पर्पल स्ट्रिप का एरिया विल डेफिनेटली ट्रेस आउट द लेसर वैल्यू. पर्पल स्ट्रिप्स का एरिया विल डेफिनेटली ट्रेस आउट लेसर वैल्यू. यस और नो? माने पर्पल स्ट्रिप्स विल बी गोइंग फ्रॉम इंटीग्रल ऑफ 2 टू हाउ मच? 2 टू n. 2 से लेके n तक जाएगा ये स्ट्रिप, फिर ये स्ट्रिप एंड सो ऑन टिल द लास्ट स्ट्रिप इज दिस. ये स्ट्रिप होगा. सो 2 टू n तक जाएगा ना. ये हाइट तो n है, ये तो n है ना. n+1 will give you the next strip. So n is this. So 2 से लेके n तक will give you the area of the purple strips over here. ठीक है, so x log x dx will give you this entire ये जो purple strips का एरिया चलेगा. ये लेसर वैल्यू देगा तो लोएस्ट मिनिमम the minimum value will be taken by this. And what is the maximum value? We have to decide this upper limit as well. What is the maximum value? Maximum value के लिए क्या करोगे? You will take the bigger strips over here. ये next वाला लेके यहाँ पे पेस्ट कर दो, ये लेके यहाँ पे पेस्ट कर दो, ये लेके यहाँ पे पेस्ट कर दो, ये लेके यहाँ पे पेस्ट कर दो. वही सेम लॉजिक. ठीक है ना? ये लेके यहाँ पे पेस्ट कर दो, नेक्स्ट वाला लेके यहाँ पे पेस्ट कर दो, फिर नेक्स्ट वाला ये वाला लेके यहाँ पे पेस्ट कर दो. ठीक है, so you will be getting more areas over here. You will cover up more areas. You will cover up more areas like this. समझ पा रहे हो? So what is this green strips over here? So we need to figure out the area of this green strip. तो ये कहां से स्टार्ट हो रहा है? It's actually starting from the second strip. If you figure out, we have taken this strip, and we have pasted over here. So it's starting from the third strip. No, it's basically it's starting from 3. So technically this will be integration 3 to n+1. 3 to n+1. फिर ये वाला स्ट्रिप क्या करोगे, ये वाला स्ट्रिप के लिए क्या करोगे, फॉर द लास्ट स्ट्रिप व्हाट विल यू डू, यू विल टेक दिस थिंग एंड पेस्ट इट ओवर हियर, ये लेके यहाँ पे ये जो मिलेगा ये लेके यहाँ पे पेस्ट करोगे, मींस बेसिकली वी आर टेकिंग टिल n+1, ठीक है, ये हाइट क्या होगा n+1, सो 3 से लेके n+1 तक एंड देन x log x dx, and then x log x dx. This is what we are having final. ठीक है, and next what do we have to do, we have to take limit as well. खाली लिमिट ही लेना है, डिवाइड भी तो मारना है, डिवाइड बाई n स्क्वायर log n एंड देन टेक द लिमिट, ठीक है, डिवाइड बाई n स्क्वायर log n एंड देन टेक द लिमिट। तो पहले ये सॉल्व कर लेते हैं, पहले ये सॉल्व कर लेते हैं। वी आर हैविंग x log x dx नो, सो वी हैव टू इंटीग्रेट दिस बाय पार्ट्स, वी हैव टू इंटीग्रेट दिस बाय पार्ट्स, ठीक है। So x log x dx means log x times of x square by 2, fine, minus of log x तो हो गया log x का डिफरेंशिएशन, ठीक है, log x का डिफरेंशिएशन 1/x, ठीक है, x टाइम्स ऑफ x स्क्वायर माने x हाफ टाइम्स ऑफ 2x माने हाफ टाइम्स ऑफ x स्क्वायर by 2, and your range of integral goes from 2 to n, ठीक है, and less than summation r is equal to 2 to n r log r, ठीक है, r log r बोलो कि x log x whatever, we are taking the summation from r is equal to 2 to n, वो तो स्टडी के लिए just to study the behavior of this thing I have taken x log x, this is basically less than log of x log x, so x log x is basically again same logic, same चीज आएगा, so log x into x square by 2, यही चीज आएगा, log x into x square by 2 minus half times of x square by 2 over here, so this becomes this goes from, अच्छा ये वाला range is going from 3 to n+1, ठीक है, this is going from 3 to n+1, so finally we are having this thing, and ये सिर्फ नहीं करना है, you have to evaluate this limit, so क्या करना है कि you have to divide by n square by log n square divided by n square log n divided by n square log n divided by n square log n divided by n square log n, you have to divide by n square log n and then you have to continue, ठीक है, you have to divide by n square log n and then you have to continue, फिर लिमिट ले लेना है, फिर क्या हो जाएगा, सैंडविच रूल से you will conclude, yes or no, by sandwich rule you will conclude this thing। अब आपको क्या करना है, बेसिकली you have to just solve these two, upper limit and lower limit separately solve कर लो, मिल जाएगा, what my point, so limit n tends to infinity, limit n tends to infinity log x into x square by 2, तो ये आ जाएगा क्या, n square by 2 log n, n square by 2 log n है कि नहीं, n square by 2 log n, then we are having minus half times of similarly n square by 4 है कि नहीं, minus n square by 4, फिर माइनस लोअर लिमिट डालो, फिर माइनस log 2 2 square by 2, ठीक है, माने 2 log 2, तो 2 log 2 और फिर +1, माइनस माइनस प्लस तो +1 है कि नहीं, यहाँ पे 2 स्क्वायर आएगा, 2 स्क्वायर डिवाइडेड बाई 2 टाइम्स ऑफ 2, तो कैंसिल आउट, तो क्या आ जाएगा +1, यस और नो, एंड डिवाइडेड बाई n स्क्वायर log n, divided by n square log n, divide मार दो, divide this thing, so once you divide this thing divided by n square by 2, तो ये अगर डिवाइड करोगे ना, I am just solving the lower limit, so limit n tends to infinity, limit n tends to infinity, n square log n cancels out, half is remaining, yes or no, इंडिविजुअली डिवाइड मारोगे तो क्या हो जाएगा, कैंसिल आउट, हाफ इज रिमेनिंग, हाफ, फिर n square cancels out, तो 1/4 log n minus 1/4 log n is remaining, yes or no, n square cancels out, 1/4 log n, अच्छा, फिर 2 log 2 divided by n square log n, 2 log 2 divided by n square, 2 log 2 plus 1 divided by, ये कांस्टेंट पूरा डिवाइड मार दो, n square log n, ठीक है, चलेगा, that's what we are having फाइनल में जाके। तो now can you see from here that we are getting half minus 4 log n, 1/4 log n, so 1/4 log n as n tends to infinity will tend to 0, definitely yes, क्योंकि 1/log n है, and 1/infinity will tend to 0, and similarly here also constant divided by n square log n, constant divided by n square log n, similarly देखो minus 2 log 2 plus 1 whatever, We are having constant divided by n log n. This also tends to 0. क्योंकि क्या होगा? As n tends to infinity, this will tend to 0. ये पूरा fraction will tend to 0. माने half minus क्या हो जाएगा? Half minus 0 minus of 0, which is basically half only. So lower limit will be half, and similarly you can calculate this upper limit, that will be also half. So I'm leaving out this upper limit calculation for you all. ठीक है? तो similarly you will calculate this upper limit. ये भी calculate करोगे तो you will get half only. तो answer will be C. ठीक है? So by summation means by sandwich theorem, this answer will be equal to half. Acha. For the next question, which says that for every increasing function b such that 1 to infinity to 1 to infinity, a function b which is going from 1 to infinity, and codomain is also 1 to infinity, such that integration 1 to infinity dx upon b of x is less than infinity. This simply means that this integral is convergent. This symbol simply means that this integral is convergent. तो बोल रहा है कि if this is convergent, then which of the series is convergent? Again, the similar logic will work out. ठीक है? तो यहाँ पे अगर options देखोगे, तो first thing is how do we solve this question? Just look at the options. Options are log k, log is there, ठीक है ना? Log is there, then e raised to the power of x is there. Okay, summation देखो, ठीक है? x है कि k, whatever. So we are getting k goes from 1 to infinity, log of k divided by b of k. माने या तो log x is there, नहीं तो e raised to the power of x is there. ठीक है? So both are convertible on over here. So what I am doing is I am taking that x to be e raised to the power of t over here. I am taking this substitution x is equal to e raised to the power of t. Why will I take this thing? यहाँ पे एक option दिखाई दे रहा है कि e raised to the power of k is there, t is there. ठीक है? k बोलो, t बोलो, whatever. And नहीं तो log x is there basically. So I am taking x to be e raised to the power of t. So what is dx? dx will be e raised to the power of t times of dt. ठीक है? So this integral will convert to integration. अच्छा, range भी change करना है. So as x tends to 1, t will be what? T will be log x. T will be what? Log x. ठीक है? तो ये तो values of x are given. Values of x are given. So if x is 1, तो t will be what? 0. है ना? And when x is infinity, this will be t will be also infinity. So 0 to infinity e to the power of t, क्योंकि dx is what? E raised to the power of t dt. तो e raised to the power of t dt और divided by क्या? b of x माने b of e raised to the power of t. तो ये ऑप्शन जैसा कुछ सिमिलर तो आ रहा है, e raised to the power of k divided by b times of e raised to the power of k. माने ये अगर बोल रहा है कि if this, so what we have done is we have just converted this integral. So what is this saying is, if this integral is convergent, then the summation series will be also convergent. क्योंकि ये approximately summation ही तो है. This is approximately k is equal to 1 to infinity e raised to the power of k divided by b times of e raised to the power of k. अब आप बोलोगे सर this range is going from 0 ना? So what? If this is convergent, then this integral is also convergent. अगर ये convergent है तो one is starting after, right? One is starting after 0. So if this integral is convergent, then this is also convergent. Same function, only range is changing. ठीक है? तो बोल रहा है कि if 0 to infinity में convergent होता है, so this is also convergent in 1 to infinity as well. So we have this series. So if this is convergent, then this series is also convergent. क्योंकि ये क्या है? What is this? This is nothing but this series represents the approximate sum, है ना? Approximate sum of this particular strips over here, of all these strips over here, है कि नहीं? तो ये integral अगर convergent होता है, तो this summation will be also convergent. So hence option C is correct. Okay, the next question says, if psi is a function which is going from R to R and it's a continuous function with integral of -1 to 1, psi of x dx is equal to 1, and f such that R to R be a differentiable function, then we have to find out the value of this limit. Limit epsilon tends to 0, 1 by epsilon, integration goes from -1 minus epsilon to 1 plus epsilon, f of y times of psi of 1 minus y divided by epsilon dy. So first of all, there are certain variables which you need to take care of. Certain things are given and certain things which you need to take care of. So first thing is here epsilon. Epsilon is basically constant with respect to this integral. This integral is dependent on y. Integral is dependent on y. ठीक है? तो ये शुरू कहाँ से? अच्छा. This integral is dependent on y and not epsilon. So what I do, first of all, I try to simplify this integration as much as possible. क्योंकि आपको simplify ही करना है, whether this simplification is not possible. So you need to simplify because आपको proof क्या करना means you have to find the value of this integral over here. ठीक है? I'll try to simplify this first and then I'll work out. Directly ना करके I'll try to simplify this and then I'll work out. So what I do is, we are having this thing, no? We are having 1 minus y divided by epsilon. So what I'll do is I'll take this as t. ठीक है? I'll take this as t. So what will happen? Y will be equal to 1 minus epsilon t. ठीक है? So I'll convert this dy in terms of t itself. And I'll try to simplify. So dy is what? Minus of epsilon dt. ठीक है? हो जाएगा यहाँ से convert. Also, you change the range of this thing. So y and t change कर लो. ठीक है? Y is going from 1 minus epsilon. So when y is 1 minus epsilon, ठीक है? तो t will be 1. Check कर लो यहाँ पे. Put the value of 1 minus epsilon over here. So if y is 1 minus epsilon, t will be 1. And if y is 1 plus epsilon, t will be minus 1. तो ये 1 है तो ये -1 ही होगा. माइनस साइन चेंज हो रहा है. So if 1 minus epsilon है, ये 1 plus epsilon होगा. Sorry, if 1 minus epsilon, then the lower limit is basically 1. And for 1 plus epsilon, the upper limit is -1. ठीक है? यहाँ पे चेक कर लेना. यहाँ पे रख के चेक कर लो. 1 minus epsilon t. 1 cancels out. What is remaining? Minus cancels out. Epsilon is equal to epsilon t. Epsilon cancels out. ठीक है? तो what is t? 1. तो limit epsilon tends to 0. Integral of, we are having now integral of 1 by epsilon times of integral of. New range is going from, look at the new range. The new range is now a constant. है कि नहीं? New range is just a constant over here. So this is basically my 1 to -1. ठीक है? 1 to -1 and dy is minus epsilon t dt. तो dy जो है minus epsilon dt होगा. And f of y is basically, what is f of y? F of 1 minus epsilon t. क्योंकि y तो ये लिया, you have to convert in all terms of t. और ये क्या है? Shy of. We have taken this to be shy of t. अब देखो पूरा t में आ गया. Now we are having a simpler expression now. ठीक है? तो ये जो epsilon है, this and this will cancel out. This epsilon and this epsilon will cancel out. ये जो minus sign है, this you all can adjust this minus sign with this integration का limit. ठीक है? Epsilon cancels out. ये जो minus है ना, so minus, can we just adjust this minus sign and write this as integration -1 to 1? ये 1 to -1 है, तो minus को adjust करके लिख दो -1 to 1. Hope you all know this basic property. So f of 1 minus epsilon t shy of t dt. है कि नहीं? That's what we are having final में जाके. तो next क्या करना है basically? Now you all can clearly see from here that we can take this limit inside. So next you can take this inside. Now there is some condition to take this limit inside this integral. Here, because the limit is dependent on t and the limits are constant, there is no function of t or variable t is present over here. So in that cases, you all can, you can take this limit inside this particular integration. Otherwise, there are some conditions. You cannot always directly take this, epsilon over here. Okay. So what I do is basically, so ye just simply take this limit inside this integral. So this becomes f of 1 minus epsilon tends to 0. माने this will tend to 0. ये 0 हो जाएगा. So this will become f of 1 times of shy of t dt. So f of 1 you all can take this out, and you are left out with integration -1 to 1 shy of t dt. -1 to 1 shy of t dt. Clear है? And shy of t dt is given in the question. Shy of x bolo ki t bolo. Integration -1 to 1 shy of x dx is given to be 1. So this is nothing but f of 1 times of 1, which is f of 1 only. Directly this is f of 1. So hence option A is correct. Okay, so next we move to this question from UGB. This question was asked in UGB. So find with proof all possible values of t such that limit n tends to infinity, this quantity is equal to c for some real number c greater than 0, and also find the corresponding values of c. ठीक है? तो करना क्या है basically? We have to solve this limit, find the value of t and find the value of c as well. For some corresponding value of t, we need to find the value of c. And this was one of the easiest problems of the question paper from UGB. ठीक है, ये तो क्लियरली दिख रहा है कि रीमैन सम से हो जाएगा. दिस इज बेसिकली लिमिट n टेंड्स टू इंफिनिटी. The first thing is whenever you see such kind of things, so what is the best thing is you first try to express this in terms of summation. So we have summation r is equal to 1 to n. R is equal to 1 to n. This is basically what 1 plus 2 and so on. तो summation क्या होगा? R raised to the power of 1 by n, 1 by 3, sorry. R raised to the power of 1 by 3. और फिर क्या? नीचे divided by n to the power of t. नीचे divided by n to the power of t is equal to c. N is just a constant with respect to this summation. Now the thing is, we have just evaluated, I mean, we have just rewritten this thing, whatever they've given in the question. ये C तो हमें निकालना है. Basically, you need not just write down the C continuously. C तो we have to find out C over here. So next, what I try to do is I'll try to write this in the form of f of r by n and 1 by n over here. So we have limit n tends to infinity. Limit n tends to infinity. 1 by n. 1 by n ले लेते हैं यहाँ पे. 1 by n. ठीक है. और फिर summation r is equal to 1 to n. ठीक है. r by n. R by n whole to the power of 1 by 3. देखो, forcefully I have taken out 1 by n and I have taken r by n whole to the power of 1 by 3. How many n's I have taken? ये जो n है यहाँ पे n to the power of 1 by 3 I have taken and also n to the power of 1 by n, माने n to the power of 1 extra n I have taken over here outside, क्योंकि ये चाहिए हमें. We want to express this in this form. We want to express this in this form. ठीक है. तो देखो ये 1 by n तो क्वेश्चन में 1 by n was not there. R by n whole to the power of 1 by 3. ये n to the power of t was there. ये n to the power of t was there. समझ पा रहे हो ना? N to the power of t was there. So what extra I have taken, I have to balance this thing. Total how much we have taken? Total basically I have taken 1 plus 1 by 3. माने 4 by 3 I have taken. N to the power of 4 by 3 I have taken, है ना? N to the power of 4 by 3 I have taken. So I'll write this as n to the power of t minus 4 by 3. Balance हो गया. Now n is balanced. तो नीचे we are having limit n tends to, ये चीज देखो, limit n tends to infinity. Limit n tends to infinity. We are having summation. ये तो summation है ही. ठीक है, माने 1 by n times of summation r is equal to 1 to n और फिर r by n times of whole to the power of 1 by n और फिर नीचे we are having n to the power of t minus 4 by 3. So now you can figure out this upper part is nothing but integral. Integral 0 to 1 x to the power of 1 by 3 dx. This upper part is nothing but integration 0 to 1 x to the power of 1 by 3 dx. ये 0 to 1 क्यों आ रहा है? 0 to 1. I hope you all remember this process. क्या आपको ये प्रोसेस याद है कि ये फॉर्म जब आपको दिख जाए, when you are seeing this form, अपर लिमिट कैसे डिसाइड होता है? अपर लिमिट इज डिसाइडेड बाय, देखो, अपर लिमिट एंड लोअर लिमिट इज डिसाइडेड बाय अपर वैल्यू ऑफ r डिवाइडेड बाय n एंड लिमिट n टेंड्स टू इंफिनिटी. डायरेक्ट फॉर्मूला से आ जाएगा. r by n इज रिप्लेस बाय x. ठीक है, तो वहां पे अपर लिमिट एंड लोअर लिमिट क्या था? अपर लिमिट ऑफ द समेशन वाज गोइंग फ्रॉम r इज इक्वल टू 1 टू n, है ना? यही तो था. r was going from 1 to n. So your upper limit will be limit n tends to infinity. Limit n tends to infinity. Upper value of r divided by n. Upper value of r माने n, तो n by n माने क्या? 1 हो गया. And lower limit, to decide the lower limit क्या होगा? Limit n tends to infinity. ये डायरेक्टली आपको दिख जाएगा प्रैक्टिस से. So lower limit or lower value of r माने 1, तो 1 by n, and 1 by n माने as n tends to infinity 1 by n will tend to 0. इसीलिए इंटीग्रेशन 0 to 1 हो रहा है. ठीक है, एंड सिमिलरली सी 1 by n has been replaced by dx. Summation has been converted with integration. 1 by n has been replaced by dx, and this function r by n has been replaced by x. So this becomes a function of x now. और फिर नीचे जो भी है, whatever we are having, नीचे we are having limit n tends to, नीचे we are having limit n tends to infinity n to the power of t minus 4 by 3. ये चीज आ रहा है. ऊपर वाला सॉल्व करोगे तो we will be getting 1 by 3 plus 1 माने x to the power of 4 by 3 and 3 by 4 will come down. X to the power of 4 by 3. Range goes from 0 to 1 और नीचे आएगा limit n tends to infinity whatever n to the power of t minus 4 by 3. ऊपर वाला पार्ट आएगा, ऊपर वाला पार्ट जो आएगा that will become 3 by 4. ये तो 3 by 4 ही आएगा और 3 by 4 divided by something like limit n tends to infinity. At this limit we have to figure out this limit n to the power of t minus 4 by 3. So we have t minus 4 by 3 here. We have t minus 4 by 3. So t minus 4 by 3 can be positive. I mean, t can be more than 4 by 3 or t can be less than 4 by 3. ठीक है? If t is more than 4 by 3, if t is more than 4 by 3, what will happen? This quantity, नीचे वाला quantity will tend to this quantity. If t is more than 4 by 3, then this, as n tends to infinity, this quantity will tend to infinity. And something by infinity will tend to 0. Constant by infinity will tend to 0. This will tend to 0. मतलब क्या है कि c ये जो c है ना, c 0 हो जाएगा, and c cannot be 0. They have said c must be positive, strictly positive. So c cannot be 0. So t cannot be more than 4 by 3. Now can t be less than 4 by 3? Now if t is less than 4 by 3, this will be negative. Power is negative. Let's say negative, n raised to the power of something negative. ठीक है, n raised to the power of minus half, let's say. तो वो तो once you take this minus half in the numerator, that will become what? Positive. ये अगर negative है ना, तो ये तो देखो 1 by n raised to the power of negative है, तो you can write this as n raised to the power of positive in this sense. So as n tends to infinity, this will tend to infinity. मतलब total thing क्या हो जाएगा? Total thing will tend to infinity. Total thing will tend to infinity. And c has to be some constant value. So again, t cannot be less than 4 by 3. अपने लैंग्वेज में ये लिख लेना. So t is less than 4 by 3. ठीक है, ये हो नहीं सकता. So definitely only possibility is t must equal to 4 by 3. Only possibility is t is equal to 4 by 3. And if t is equal to 4 by 3, then c will be what? t क्या होगा? जब ये t 4 by 3 हो जाएगा, this will become 4 by 3 minus 4 by 3, which is 0. n raised to the power of 0 is 1. नीचे 1 हो जाएगा. Answer will be 3 by 4. So if t is 4 by 3, c will be what? C is actually 3 by 4. So we have found out t, and corresponding to t, we have found out c as well. Next we come down to the PYQs of 2023. Ajao. So we have this question. We have limit n tends to infinity, n to the power of minus 3 by 2, n plus 1 raised to the power of n plus 1 multiplied by n plus 2 raised to the power of n plus 2, and so on till 2n. This 2n mane n plus n basically. So n plus n raised to the power of n plus n, and then whole raised to the power of 1 by n square. ठीक है? So we have to evaluate this particular limits over here. ठीक है, तो ये Riemann sum का ही क्वेश्चन है. ये काफी सिंपल क्वेश्चन है. You can try to express this in terms of Riemann sum, but first of all, the only problem is over here we have some powers in the मतलब ये जो लिमिट है, लिमिट के यहाँ पे पावर है 1 by n square is there actually. ठीक है? So what do we do to convert this power? So first of all, तो we have to rewrite this thing. The first thing is we need to rewrite this thing, and पहले ये चीज कर लेते हैं. So we are having limit n tends to infinity. We are having limit n tends to infinity, n to the power of minus 3 by 2. N to the power of minus 3 by 2 times of. So we are having n plus 1 whole to the power of n plus 1. ठीक है? What I'm doing is, first I'm taking out n common from all the terms. I'm taking out n common from all the terms. So n to the power of n plus 1, फिर 2 to the power of, n to the power of n plus 2, and so on. I'm taking out n common from all the terms, goes up till n to the power of n plus n. ठीक है? हर एक टर्म से n कॉमन गया है. सो व्हाट इज रिमेनिंग? 1 plus 1 by n whole to the power of n plus 1, then 1 plus 2 by n whole to the power of n plus 2, and so on. This goes up till 1 plus n by n, 1 plus n by n whole to the power of n plus n. That is what is remaining, right? ठीक है, ये ध्यान रखना कि ये जो 2n है, 2n is nothing but n plus n whole to the power of n plus n. ठीक है? Such kind of basic chalakis will be done. तो ये आपको पकड़ना है. So whole raised to the power of 1 by n square. So now what can we do from here is limit n tends to infinity. ठीक है? So we have taken out this thing, all sort of n's over here. So we are having n to the power of minus 3 by 2. We can simplify this and write this as n to the power of n plus 1 plus n plus 2, and so on till n plus n. ठीक है? n plus 1 plus n plus 2, and so on. Compile कर लेते, which is n plus n. ठीक है? And this is 1 plus 1 by n, whatever we are having, up till 1 plus n by n, 1 by n square. That's what we are having. तो ये जो पार्ट है, ये डायरेक्टली यहीं पे लिख देते हैं basically. Let's not waste 2-3 more lines over here. ये क्या है? What is this? n and so on. How many times of n? So n raised to the power of n is there. ठीक है? वरना ये तो आप लोग देख ही सकते हो कि what is this? AP is there, no? ये तो AP है basically. n by 2 times of what is this? n by 2 times of नंबर ऑफ टर्म्स क्या है n, तो n by 2 टाइम्स ऑफ n plus 1 माने 3n plus 1, this will become n plus 1 plus n first term plus last term माने n plus 1 plus n plus n माने 3n plus 1, ठीक है। अरे n by 2 टाइम्स ऑफ फर्स्ट टर्म प्लस लास्ट टर्म, फॉर्मूला ऑफ एपी, ठीक है कि नहीं, चलेगा। So we are having this much, we have simplified this much, so this is if I try to more simplify this thing, so this is actually n raised to the power of minus 3 by 2 and this is n by 2, so one of this n will come over here, so we have n by 2, n raised to the power of n by 2, n raised to the power of n by 2, ठीक है। और फिर नीचे यहाँ पे 3n plus 1, 3n plus 1 चलेगा, 3n plus 1। इसको एक काम कर लेते हैं ना, we can just bring this outside the bracket itself, let's simplify this and bring this outside the bracket, so can we divide this thing, let's bring this outside the bracket, we have 1 by n square, so I'm bringing this outside, so we have divided by n square over here, so we are having 1 plus 1 by n, 1 plus 1 by n whole to the power of n plus 1 and so on so forth up till 1 plus n by n whole to the power of n plus n raised to the power of 1 by n square। फाइनल में जाके यही चीज बचेगा, यस और नो, है ना। तो फाइनली वी आर हैविंग this and after simplification let's see what are we getting, so we are having limit, ये simplify करके क्या आ रहा है वो, this is one of this n is getting cancelled over here, right, so we are having this to be, ये कितना आएगा, माइनस ऑफ 3 by 2, माइनस ऑफ 3 by 2, ये देखो माइनस ऑफ 3 by 2 आ रहा है यहाँ पे, और यहाँ पर भी देखो 1 n and n will cancel out once you divide, so we have plus 3 by 2 and this is plus half, plus half, plus half नहीं, plus 1 by 2n, plus 1 by 2n, so 3 by 2 and 3 by 2 cancels out, so n to the power of 1 by 2n is remaining, तो फाइनल में जाके this will get simplified and this will become n to the power of 1 by 2n, so limit n tends to infinity, this is n to the power of 1 by 2n, ठीक है, and then 1 plus 1 by n whole to the power of n plus 1, ठीक है, and so on till 1 plus n by n whole to the power of n plus n whole to the power of 1 by n square। So final में we are having this and now we try to simplify this thing, now it's easy to simplify, we take log on both the sides and then we simplify this thing, ठीक है, log तो लेना ही है यहाँ पे, we are taking log on both the sides, so log a will be taken log on both the sides, ठीक है। तो log लोगे तो डायरेक्टली this will become limit n tends to infinity, this quantity, this will become log a plus log b हो जाएगा, प्रोडक्ट में तो log a plus log b, तो डायरेक्टली आई एम राइटिंग, तो ये प्रोडक्ट लोगे तो log a plus log b, और यहाँ पर भी एक प्रोडक्ट है, सॉरी नॉट प्रोडक्ट, बेसिकली पावर है यहाँ पे, पावर इज 1 by 2 to the power of n, so 1 by 2 to the power of n will come down, ठीक है। So directly I'm taking the limits over here. So limit n tends to infinity 1 by 2 to the 1 by 2n log times of log n. ये बचेगा and plus limit n tends to infinity, limit n tends to infinity 1 by n, ठीक है, 1 by n will come down and this is log of this thing now 1 by n square will come down, ठीक है ना, ना wait 1 by n square नहीं लाएंगे, 1 by n, we need 1 by n, ठीक है, let us distribute this n over here, let us distribute this n, one of this n over here, क्या बोलते हो, let us distribute this one of this n, let's bring down one of this n over here, एक n नीचे लाएंगे और बाकी एक n दे दो इसको, just give one of this n to this power, ठीक है, समझ पा रहे हो ना what I'm trying to say, because we need 1 by n, फॉर्म तो वही है ना 1 by n times of summation, so what I'm trying to say is distribute this n in each of them, यहाँ पे n square था, so you're distributing this n और बाकी जो n है वो नीचे ले आओ, because we need 1 by n, समेशन ये हो जाएगा समेशन log of, ठीक है, log a plus ये देखो this will become what, log a times of log b times of log c and so on, तो वो समेशन में आ जाएगा ना, समझ पा रहे हो ना, तो समेशन ऑफ log of 1 plus r by n, 1 plus r by n and then whole to the power of 1 plus r by n, मानते हो कि नहीं, r is going from 1 to n. ये क्लियर है ना? ये स्टेप क्यों किया? व्हाई वी हैव डन दिस स्टेप? 1 plus 1 by n whole to the power of this becomes 1 plus 1 by n. Next term is what? 1 plus 2 by n. Last term is what? 1 plus n by n. ठीक है? So what is changing? This is changing now. 1 plus n by n, 1 by n, 2 by n and 3 by n and so on. This is changing in this sense. तो यही चीज बचेगा, हाँ या ना? r is going from 1 to n. क्लियर है? So this is finally we are having limit n tends to infinity. Limit n tends to infinity 1 by 2 to the power of 1 by 2n times of log n. अच्छा, ये क्या करोगे? हाफ तो कांस्टेंट है, हाफ इज जस्ट अ कांस्टेंट, सो यू कैन टेक दिस आउट. बाकी log n by n इज देयर, सो log n by n क्या करोगे? l'Hopital's रूल यूज कर लो. log n by n माने 1 by n डिवाइडेड बाय 1. ठीक है? And plus limit n tends to infinity. What about this? How do we solve this? This is basically integration 0 to 1. 1 to n जा रहा है ना, तो क्या होगा? 0 to 1. वही फॉर्मूला यूज कर लो. क्या हो जाएगा? log of 1 plus x whole raised to the power of 1 plus x. क्लियर है कि नहीं? dx. तो this 1 plus x will come down. So final में this is what n tends to infinity माने this will tend to 0. तो फाइनल में जाके क्या बचेगा? इंटीग्रेशन 0 to 1 1 plus x log of 1 plus x dx. So next we have to integrate this by parts. इतना ही आपको करना है. We have to integrate this by parts. ठीक है? तो आपने प्रूफ ये किया है, तो now we have to solve this integration. We have to integrate this by parts. So we are having integration 0 to 1 1 plus x log of 1 plus x dx. तो ये बाई पार्ट से ही आपको सॉल्व करना है, right? And you all can do this thing. To simplify this thing, you all can take 1 plus x as t and then solve. ये t कर लो, dx is dt. डायरेक्टली भी किया जा सकता है. Otherwise you take 1 plus x as t, so dx is dt, and x and t, x is going from 0 to 1. So when x is 0, t will be 1, and when x is 1, t will be 2. So integration going from 1 to 2. ठीक है? And this is basically t log of t dt. ठीक है? तो ये log of t just now, few minutes back we have solved. What is t log of t? माने x log x dx है ना? log of t into t square by 2, और माइनस यहाँ पे क्या आ जाएगा? माइनस दिस विल बिकम t square by 2. ये हाफ आ जाएगा, माने 1 by t times of t square by 2. इंटीग्रेशन 1 by 2 times of 1 by t times of t square by 2, माने ये क्या आ जाएगा? दिस विल बिकम t by 2 ओनली, है कि नहीं? 1 by t times of t square by 2, t will cancel out, तो t by 2 ही बचेगा. हाफ बाहर कर लेते हैं, यहाँ पे t बचेगा. डायरेक्टली आई एम राइटिंग. समझ पा रहे हो ना? और ये भी यहाँ पर भी रेंज इज गोइंग फ्रॉम 1 to 2. रेंज आप डायरेक्टली भी डाल सकते हो, मींस आफ्टर सॉल्विंग ऑल द थिंग्स यू कैन डायरेक्टली प्लग इन द रेंज ओवर हियर, वो भी चलेगा. ठीक है? तो ये फाइनल में जाके क्या आ रहा है? ये बन रहा है 2t, ये 2 log t. ठीक है? तो बेस्ट थिंग इज आई गेस द रेंज फाइनल में जाके डालेंगे. ठीक है? रेंज पूरा सॉल्व कर ले, फिर डालेंगे रेंज. क्या बोलते हो? 1 to 2. सो दिस इज बेसिकली log ऑफ t टाइम्स ऑफ t स्क्वायर बाई 2, और यहाँ पे हाफ टाइम्स ऑफ, यहाँ पर भी t स्क्वायर बाई 2 आएगा. ठीक है? तो 4 कर दो इसको, t स्क्वायर कर दो इसको, एंड देन रेंज इज गोइंग फ्रॉम 1 to 2. तो log ऑफ 2 स्क्वायर बाई 2 माने 4, ये 4 आएगा 4 by 2, तो 2 log 2 माइनस ऑफ 1 by 2 टाइम्स ऑफ 2 स्क्वायर, तो 4 and 4 विल कैंसिल आउट. ठीक है? और फिर माइनस ऑफ log 1 0, और फिर माइनस माइनस प्लस 1 by 4. ये चीज आएगा फाइनल में जाके. सो 2 log 2, this finally becomes 2 log 2 minus 1 plus 1 by 4. So this is basically 2 log 2, and this is minus 3 by 4. So minus 3 by 4. ये 2 log 2 माने log 4. 2 log 2 माने log 4. So this is actually log 4 minus 3 by 4. Minus 3 by 4. अच्छा, तो आंसर इज गिवन इन पावर्स ऑफ e. ठीक है? तो यू आर सॉल्विंग फॉर, ये याद रखना, यू आर सॉल्विंग फॉर log a. आपने ये प्रूफ किया है कि log a इज इक्वल टू log 4 माइनस 3 by 4. आपने ये प्रूफ किया है. ठीक है? This is what we have proved. So A is what? A is e to the power of log 4 times of e raised to the power of minus 4. So e raised to the power of log 4 mane 4 only, and this is 4 times of e raised to the power of minus 4. So 4 times e raised to the power of minus 4, option D is correct. Okay, so next we have this question. Let fg be continuous functions from 0 to infinity to itself. Hx is one function given to be this, and capital of fx is this function given to be this. So f dash is the derivative of f. Then for x greater than 0, what is f dash of x? So it's a pure question of Newton-Leibniz rule. So I've given this rule over here. What is this Newton-Leibniz rule? ठीक है, तो ये rule ध्यान रखना. So we are going to use this thing only. So Newton-Leibniz rule is basically something, if we have to differentiate one integration which is having variable limits, ठीक है? So in that case, we have to use this Newton-Leibniz rule. I hope you all know this thing. So what is this? Basically, first we are having this hx and this fx given. So what you have to find? You have to find out this f dash of x. F dash of x माने मेन चीज जो है इसको डिफरेंशिएट करना है. We have to differentiate f. ठीक है, तो f को डायरेक्टली यहाँ पे डिफरेंशिएट कर देते हैं. So what is f dash? F dash of x will be this will be g of, देखो, t will be replaced by the upper limit g of hx into differentiation of this upper limit which is h dash of x. ठीक है, और बाकी तो माइनस 0 है, तो दैट विल गिव यू 0 ओनली. g of 0 टाइम्स ऑफ डिफरेंशिएशन ऑफ 0 is 0 only, so that will be 0. ठीक है, so this is your f dash of x. ये f dash of x है. अब मेन चीज है कि यहाँ पे h dash of x is there and h of x is also given in the question. h of x is also given in the question. And options में देखो, all of them are in terms of g of hx. g of hx is present in all the options, so you need not find what is g of hx. So h dash of x we can find from here. What is h dash of x? Again, we can find h dash of x by Newton-Leibniz. तो क्या हो जाएगा? This will become f of upper limit, which is 3 raised to the power of x. The variable will be replaced by this upper limit f of 3 raised to the power of x. यही तो बोल रहा है यहाँ पे रूल पे. ठीक है, into differentiation of 3 raised to the power of x, which is 3 raised to the power of x log 3. ठीक है, and minus f of 2 raised to the power of x into log of 2. That's how we differentiate derivative. Yes, that's all. And what we are done. So next is what? You simply place it over here. So we have g of hx multiplied by h dash of x, which is f of 3 raised to the power of x into 3 to the power of x into log of 3 minus f of 2 raised to the power of x into log of 2. ठीक है, f of 2 raised to the power of x, यहाँ पे एक और 2 raised to the power of x आएगा. सॉरी, I missed out this thing. यहाँ पे एक और 2 raised to the power of x आएगा. f of 2 raised to the power of x into 2 raised to the power of x times of log of. Differentiation of a raised to the power of x is a raised to the power of x times of log of a. तो वही चीज हो रहा है यहाँ पे. So into 2 raised to the power of x times of log of. ठीक है, तो बस देख लो ना यहाँ पे क्या है. यहाँ पे है क्या? So 3 raised to the power of x, ऑप्शन डी लग रहा है. 3 raised to the power of x times of f of 3 raised to the power of x ln 3. ठीक है, and 2 raised to the power of x times of f of 2x 2 raised to the power of x into ln 2. और बाहर में we are having g of hx. Option D is correct. चलो, we solve this question next. Again, one easy question. So we have f such that 0 to infinity goes to r. We have continuous function such that some relation is given. ठीक है, and then for all x greater than or equal to 0, we have to search for fx basically. We have to solve for fx, right? So what I do first, I differentiate this thing, क्योंकि आपको चाहिए fx. ठीक है, आपको चाहिए fx. So what I do, I differentiate this relation over here. So what will I get from here is f dash of x. Why will I differentiate? Because f is stuck inside this integration, and to remove this variable integration over here, so the best thing is what? To differentiate. So f dash of x plus ln 2 times of integration 0 to x f of t dt. So f of t dt means this will become f of x by Newton-Leibniz into differentiation of x, which is 1. है ना? And this is equal to 0. Right hand side में constant है, तो 0. So f dash of x is how much? F dash of x will be equal to minus of ln 2 times of fx. So what we can say from here, f dash of x divided by fx is equal to minus of ln 2. And this is a very standard form of integral. You integrate both the sides with respect to x. Integrate both the sides with respect to x. तो ये क्या हो जाएगा? What is this? ln fx में simple thing. fx is equal to t. तो क्या हो जाएगा? f dash of x dx will be dt. ठीक है. So ये क्या हो जाएगा? 1 by t dt. Integral 1 by t dt. So ln fx log of t हो जाएगा, तो which is log of fx because we have taken fx to be t. तो ये तो डायरेक्ट फॉर्म्स ही होता है which is taught in definite. So ln fx is equal to minus of ln 2 times of x plus c. That's what we are having final में जाके. चलेगा? So this is basically your ln fx. You are getting some relations. Now we have to remove this constant to find out fx. Fx is still stuck over here. So to find out this fx, we have to remove this arbitrary constant for which we have to refer to this main equation. तो ये जो main equation है, यहाँ से आपको fx मिल जाएगा. So what is fx? तो यहाँ पे the simplest possible value to remove or to find the value of this constant will be to put the value of x to be 0. क्यों x 0 डालेंगे? देखो 0 to 0 ये 0 हो जाएगा. This will become 0. This term will become 0. And it's easier for you to find out the simplest possible value is what? Simplest possible value is 0 only. So it's easier for you to find out this equation. Find the value of this arbitrary constant over here. ठीक है, specific value तो चाहिए होगा c के लिए. So if x is 0, then this quantity will become 0. So f of 0 will be equal to 1. You are getting some values over here. मतलब क्या होगा कि if x is equal to 0, y is equal to 1. तो यहाँ पे डाल दो. यहाँ पे डाल दो if x is 0, y is 1. ठीक है. तो this will become what? This will become log of 1, which is 0. And similarly ये भी क्या हो जाएगा? 0. तो 0 plus c, तो c 0 आ जाएगा यहाँ पे. c will be 0. So यानी c 0. तो आपको यहां से you are getting ln fx. ln fx is basically minus of ln 2 times of x. So now we can find fx from here. What is fx? Fx will be e raised to the power of minus of x times of ln 2. So this is e raised to the power of, we can write this as, we need to rewrite this thing. So we can write this as ln e raised to the power of ln. Can I write this as 2 raised to the power of minus x? 2 raised to the power of minus x. ठीक है. So this becomes e raised to the power of ln 2 raised to the power of minus x, which is 2 raised to the power of minus x only. मतलब which is the same as half raised to the power of x. So option D is correct. Next question. So next question is based on a result actually. I've given this over here. देखो, it's a very famous thing, famous result which we see. ठीक है. ये routine, you know, it's a very routine result. And first of all, this is you know, the first time this question has been the inspiration to design this question came from a question which came in IIT. ठीक है, same year में. देखो भाई, question क्या बोल रहा है? Let function r to r be a twice differentiable 1-to-1 function if f of 2 is 2, f of 3 is minus 8, and this integral is given. We have to find integral minus 8 to 2 f inverse x dx. So first of all here, what you need to figure out, ये जो रिजल्ट है ये भी वही चीज बोल रहा है कि इंटीग्रेशन a to b fx dx प्लस इंटीग्रेशन c to d g of y dy. ये g of y क्या है भाई? g is nothing but the inverse of fx. मतलब ये this is g of y is nothing but f inverse of x dx. ये सेम चीज है. ठीक है, both of them have the same meaning. So थोड़ा स्टाइल में लिखा है ये. If this has x belongs to ab as a domain and f of a is equal to c, तो f of a is equal to c मतलब क्या है कि f of a is equal to c. This is a and this is f of a. ठीक है, and this is f of b is equal to d. So f of b is equal to d g of y dy. तब आंसर क्या होता है? आंसर इज b टाइम्स ऑफ द प्रोडक्ट ऑफ दिस माइनस प्रोडक्ट ऑफ दिस, अपर लिमिट माइनस प्रोडक्ट ऑफ लोअर लिमिट, माने bd माइनस ऑफ ac. So we will be using this theorem over here. ठीक है, तो ये जो चीज है यहाँ पे they have said this integration is given to be minus 3 and this is given to be f inverse, means we have to find out this value of this thing. So by this theorem we can say integration a to b fx dx. ठीक है, यहाँ पे क्या है? 2 to 3 fx dx. ठीक है, प्लस इंटीग्रेशन c to d. ये c to d क्या है भाई? c to d is basically c to d will come from here. ये c to d क्या? ये माइनस, क्या ये यहाँ पे f of 2 है? Is f of 2 given? Yes. f of 2 is 2 और यहाँ पे क्या आना चाहिए, हियर फंक्शन वैल्यू ऑफ f of 3 मस्ट बी देयर, f of 3 क्या ये है, हाँ -8, और यहाँ पे क्या होना चाहिए, हियर f inverse of x should be there, so g of y dy, whatever stylish way of writing this thing, so f inverse of x dx, ठीक है. So this is actually b times of, what is this formula, क्या होता है, b times of the product of this minus product of this, अगर ये होता है तो, so this is basically b times of 3 times of f of 3, 3 times of f of 3 minus of 2 times of f of 2, मतलब क्या होगा, 3 times of -8 minus 2 times of 2, माने -24 and minus of 4 which is actually -28, this is -28, ठीक है. तो ये जो चीज आ रहा है दिस इज एक्चुअली -28, ये जो चीज है ये वैल्यू तो देके रखा है क्वेश्चन में, दिस इज इक्वल टू -3, माने इफ दिस इज इक्वल टू -28 वी आर जस्ट फाइंडिंग दैट -3 प्लस इंटीग्रेशन 2 to -8 इज इक्वल टू fx f इनवर्स ऑफ x dx, यही तो चाहिए आपको, एंड दिस इज इक्वल टू -28, सो इंटीग्रेशन 2 to -8 f inverse of x dx is -28 plus 3 which is -25, but answer is not -25 because ध्यान से देखो they are asking for -8 to 2 and not 2 to -8. What is -8 to 2? तो -8 to 2 क्या होगा, answer will be 25, -8 to 2, so you are interchanging the limits, so this will be 25, so option B is correct. Subjective question, this is a nice question, देखो question क्या बोल रहा है, lot of things are there, so one by one चलो. So f such that 0 to 1 to r be a continuous function which tells us, which is a differentiable on 0 to 1, we have to prove that either f is a linear function or there exists t belongs to 0 to 1 open such that mod of f of 1 minus f of 0 is less than mod of f dash of 0, ठीक है. So what I try to do, certain things might be helpful over here because we are having f dash of t over here, we are having f dash of t, है ना. तो एक चीज तो ये चीज आप लोग देख सकते हो कि one trivial relation is known to you which is integration of a to b. There are lots of ways to prove this thing. You can prove this by direct integration wala formula, or you can prove this by you can prove this by mean value theorem as well, because you can have some feeling of mean value theorem. ये दिखाई दे रहा है ना, continuous function which is continuous on closed AB, then differentiable on open AB, prove that their f is either linear function or there exists t belongs to 0 to 1. So you can take the help of the mean value theorem to prove this thing. So I'm not showing using mean value theorem, I'm showing using some properties of definite integration or basic integration wala, basic manipulation and calculations will, you can solve this thing. So integration of, one thing I can say from here, just now we have learned this thing, integration of a to b fx dx is less than or equal to integration a to b mod of fx dx. We have learned this thing, ठीक है. तो यहाँ पे fx तो है नहीं, यहाँ पे f dash of t is there, यहाँ पे f dash of t is there, so I can use this thing, so I can say that integration of a to b f dash of t dt, ठीक है, and this is actually less than or equal to integral of 0 to 1 mod of f dash of t dt, mod of f dash of t dt, ठीक है. ये चीज आ रहा है. तो इंटीग्रेशन ऑफ f dash of t is what, fx, this is what f of t, and range goes from a to b, ठीक है. a to b नहीं, ये 0 to 1 होगा, not a to b. We are having the limits going from 0 to 1. We are having the limits going from 0 to 1. भाई 0 to 1 क्यों लेंगे, क्योंकि है क्वेश्चन में भाई देखो 0 to 1 ही है. तो 0 to 1 f dash of t dt, this will be what, this is nothing but f of 1 minus f of 0 less than or equal to integration 0 to 1 mod of f dash of t dt. ये चीज होगा, ठीक है. So one relation we are obtaining from here itself. You have to prove that fx is either a linear or there exists some this thing, some function, some t which belongs to 0 to 1 such that this is holding, ठीक है. So we are getting one relation from here. So now when this equality will hold, this equality will hold from here, from this property itself. We can say this equality will hold if f of t, if these two are having the same sign. If the modulus is having the same sign, then we can say that this equality will hold. Okay. So we are getting this thing. And we have to prove that this f of 1 minus f of 0 must be less than f dash of t. Assume that what I do is I take that, assume that mod of f dash of t is less than or equal to mod of f of 1 minus of f of 0. This is one possibility. ठीक है, क्योंकि ये तो हो रहा है, हमें तो ये प्रूफ करना है. उल्टा लेके चलो, mod of f dash of t less than or equal to mod of f of 1 minus of f of 0 for all t belongs to 0 to 1. Let's say. ठीक है. So right from here we are having two possibilities. The first case will be mod of f dash of t will be equal to mod of f of 1 minus of f of 0 for all t. Let's say mod of f dash of t will be equal to mod of f of 1 minus of f of 0. I'm taking this equality version for all t. ठीक है, for all t means all t belongs to 0 to 1. So what is the meaning of this thing? So what if I just take this integral over here, if I take this integral 0 to 1 mod of f dash of t dt on both the sides, so this becomes f of 1 minus of f of 0 dt. ठीक है, अब ये तो t आएगा, ये तो कांस्टेंट है. So what is this? Mod of f of 1 minus of f of 0 only, है ना? So we are proving one more relation. We are proving from here, that is integration of 0 to 1 mod of f dash of t dt, and this is equal to mod of f of 1 minus of f of 0. ठीक है, and this is one more relation we are proving from here itself. Integration 0 to 1 mod of f dash of t dt is equal to mod of f on 1 minus f of 0. ठीक है, अब देखो फर्स्ट वाला बोल रहा था कि फर्स्ट वन इज दिस. ठीक है, आई एम हाईलाइटिंग दिस रिलेशन ओवर हियर, तो ये ध्यान रखना. ठीक है, दिस रिलेशन इज वेरी इंपॉर्टेंट. सो फर्स्ट वाला बोल रहा है कि वी आर हैविंग दिस mod of f of 1 minus f of 0 is less than or equal to integral 0 to 1 mod of f dash of t dt. अब ये बोल रहा है कि mod of f dash of t dt is equal to mod of f of 1 minus of f of 0. So the first one and the second one. So second one बोल रहा है कि ये equal हो रहा है. Second one बोल रहा है कि ये equal हो रहा है. So these two are equal. माने these two can be put together. We can take these two. We can compile these two only if their signs are equal. बोला ना मैंने. These two will hold only if माने these two are having the same sign. The modulus are having the same sign. Only these two will hold. Getting my point? So 1 and 2 can we can compile these 1 and 2 only if they are having the same sign. Yes or no? समझ पा रहे हो what I'm trying to say? So mod of f of 1 minus of f of 0 also mod of f of 1 minus of f of 0 will be a constant function. Will be a constant. आएगा तो constant ही. We can equate these two and this will be a constant only. So I'm taking this to be a constant. ठीक है. And what is this constant? This constant is nothing but mod of f dash of t only. This constant is nothing but mod of f dash of t only. ठीक है. So mod of f dash of t, यहाँ से. So mod of f dash of t will be equal to c. माने f dash of t will be equal to plus minus c. F dash of t will be equal to plus minus c. चलेगा. तो f of t, what are the possibilities? बोल रहा है कि फंक्शन, अब देखो फंक्शन must be of the same sign. ठीक है, this must be of the same sign. तो या तो फंक्शन या तो ct plus k होगा. ठीक है, the function ft, we are getting f dash of t ना, तो फंक्शन क्या होगा? ct plus k, और नहीं तो क्या होगा? ct minus k, minus ct plus k, minus ct plus k. These are the only two possibilities, but for both the possibilities we are getting linear function. ठीक है, so we can compile these two and write this as fx is equal to, we are getting linear forms over here, fx is equal to ax plus k. where A is equal to plus minus C in both the cases. या तो Ct plus K होगा, नहीं तो Ct minus K minus Ct plus K होगा. Only two possibilities. So fx must be equal to ax plus k, where a is plus minus c. So we have just proved that there is a function, either f is linear वाला part we have proved. So ये जो function आएगा, ये function linear वाला part होगा in this case when the first case occurs. So this function will be a linear वाला part. अभी second case पे आएंगे. Second वाला थोड़ा contradiction वाला proof है. Second case पे आएंगे. One possibility was this thing. One possibility is this, where I have taken mod of f dash of t is equal to mod of f of 1 minus of f of 0. Yahan se, from this section. Let us see the second possibility. What is the second possibility? So for the second possibility, I take second possibility is case 2. Case 2 pe aa jao. First one, I have taken mod of f dash of t is equal to mod of f of 1 minus f of 0 for all t. Next, I am taking mod of f dash of t. Next, I am taking mod of f dash of t is equal to mod of f of 1 minus f of 0 for some t. For some t. For some t, I am taking this thing. वहां पे for all t था. So for some t, I am taking this is equal. And for some t, for the remaining t, I am taking mod of f dash of t is strictly less than mod of f of 1 minus of f of 0. ठीक है. For the remaining t. Some t. For some t, I have taken this is equal, and for the remaining t, it's unequal, one is strictly less than. होगा तो वही possibility क्योंकि less than or equal to था. या तो strictly less than for all t, or it's equal to for some t and strictly less than for the remaining. ठीक है. That's what we are having. So what we can say from here is, so one thing we can say from here is, if I integrate over here, so this becomes integration 0 to 1, mod of f dash of t will be also, dt will be also strictly less than integration 0 to 1 mod of f of 1 minus f of 0. ये graphically आप लोग समझ सकते हो. You all can understand this thing graphically क्योंकि mod of, देखो, mod of f of 1 minus f of 0 will be a constant function only. ठीक है. Mod of f of 1 minus f of 0 will be a constant function. और फिर बाकी जो ग्राफ आएगा f dash of t का, that will lie below this graph. तो वो जो एरिया होगा, this integration of this entire thing will be definitely less than this. ठीक है. Obvious reasons. So this is relation number 3 which we are obtaining from here. This is relation number 3 which we are obtaining from here itself. ठीक है. अब ये क्या है? What is this? 1 only, माने f of 1 mod of f of 1 minus of f of 0. ठीक है. अब देखो, we are obtaining this thing from here, लेकिन फर्स्ट वाला रिलेशन तो होल्ड करना ही है. फर्स्ट रिलेशन इज सेइंग कि mod of f of 1 minus f of 0 must be less than or equal to 0 to 1. ठीक है ना. ये क्या बोल रहा है? दिस इज स्ट्रिक्टली लेस देन 0 to 1. 0 to 1 मतलब स्ट्रिक्टली लेस देन 0 to 1 dt which is t only and which is 1 only. माने this is strictly less than f of 1 minus of f of 0. strictly less than. ये बोल रहा है कि this is strictly less than this. This is strictly less than this quantity. ठीक है. मतलब ये 3 मान लो, सपोज ये 3 है, तो 1 and 3 are technically not possible to together to be whole, है ना. 1 has to be true. समझ पा रहे हो ना. 1 and 3 together cannot hold. ठीक है. 1 has to be true and so 3 is not possible. 1 has to be true, so 3 is not possible. नहीं तो contradiction है. ठीक है. So contradiction with 1. This is a contradiction with 1. 1 तो होल्ड करना ही है. ठीक है. So this implies that above assumption is wrong. कौन सा? ये, this one. ठीक है. above assumption is wrong. तो ये सेकंड केस होल्ड नहीं होगा. assumption is wrong, and so therefore mod of fx, so this quantity mod of this thing is wrong, so therefore we can say mod of f of 1 minus f of 0 mod of f of 1 minus f of 0 must be definitely less than mod of f dash of 1. ठीक है, तो हमने ये प्रूफ किया कि प्रूफ दैट ईदर f इज लीनियर, तो एक बार हमने लीनियर प्रूफ कर दिया. सो वी आर शोइंग दैट इफ दिस इज लीनियर, माने इफ वन इज होल्डिंग एंड द सेकंड इज नॉट होल्डिंग, दैट्स हाउ वी आर प्रूविंग. ठीक है ना, फर्स्ट वाला इज होल्डिंग एंड देन सेकंड वन वी आर ट्राइंग टू प्रूव यूजिंग कॉन्ट्रडिक्शन और समथिंग. तो ये लेस देन तो होगा नहीं, दिस विल बी mod of f of 1 minus f of 0 will be less than f dash of t. I hope the proof is clear to all. So we move on to 2022 PYQs. Aja, first question. First question is saying for n belongs to n, let a n be defined as this thing. So a n is basically integral going from 0 to n, 1 by 1 plus nx square. Then we have to find limit n tends to infinity a n. This is a simple question, not that difficult. This looks like some difficult concepts of sequence has been given over here, but this is a very easy problem. So limit n tends to infinity, limit n tends to infinity. We have to find the value of this thing only. 0 to n, 1 upon 1 plus nx square. है ना, और ये तो सिंपल है, काफी सिंपल है. क्या करोगे, 1 plus nx square माने this is basically limit n tends to infinity. I rewrite this thing. ये क्या है ना, what is this? ये है रूट ओवर ऑफ nx का होल स्क्वायर, रूट ओवर ऑफ nx का होल स्क्वायर है ना. सो 1 by root n कम्स आउट, 1 by root n विल कम आउट. ठीक है, बाहर कर लो. नहीं तो एक काम करो, लेट्स डू वन थिंग. बेस्ट थिंग इज बेसिकली यू आर हैविंग 1 प्लस, ये लिख लेते हैं यहाँ पे. लेट मी जस्ट राइट दिस फॉर यू. सो दिस इज इंटीग्रेशन 0 to n. सो 1 by 1 plus रूट ओवर ऑफ nx का होल स्क्वायर dx. So rest is easy. You take root over of nx to be t. ठीक है, ये t ले लो. So basically you are getting root over of n dx is dt. ठीक है, तो ये हो जाएगा 1 by n. देखो 1 by n एक बाहर आएगा. So limit n tends to infinity, 1 by n comes down, 1 by root n comes down. ठीक है, and this becomes integration. अच्छा, lower limit will be 0 only. ये 0 के लिए 0 होगा. और when x is equal to n, this will be n root n. So n root n and 1 upon 1 plus t square dt. ठीक है, and what is this? Tan inverse limit n tends to infinity, 1 by root n, tan inverse है ना, tan inverse root n, sorry, tan inverse t, range goes from 0 to n root n. So limit n tends to infinity, 1 by root n. This is tan inverse of n root n. So next is what? Solve this limit. What else we'll do? Solve this limit. So what is this? Limit n tends to infinity, tan inverse n root n divided by root over of n. अब n root n ये तो pi by 2 आएगा, because as n tends to infinity, this will tend to infinity, which is nothing but pi by 2. Technically, you are getting pi by 2 divided by tends to infinity, which is what? Tends to 0 only. Option A is correct. Now we have this question. It says consider a differentiable function u such that 0 to 1 goes to r. Assume the function u satisfies this relation. So u of a is given to be what? U of a is given to be 1 by 2 r integral a minus r to a plus r, and then ux dx. और नीचे क्या है? Divided by 2r. ठीक है, नीचे is divided by 2r. For all a belongs to 0 to 1 and all r, for all r less than minimum of a comma 1 minus a. तो ये जो r है, r is definitely some value which is less than minimum of these two quantities. हाँ, this is the only observation which you need to see. This is nothing but the mean value property. It's the mean value theorem. This is nothing but the mean value or the average value of the function. That's how I have taught the average value of the function. Average value of the function क्या होता है? Integration a to b fx dx divided by b minus a. This is the average value of the function. यही तो होता है average value of a function fx. ठीक है, so what is this given? The average value of the function. ठीक है, ये जो नीचे 2r है ना, this 2r is nothing but, I rewrite this 2r. This 2r is nothing but a plus r minus of a minus r. ठीक है ना, b minus a plus r minus of a minus r. यही तो है 2r. So it's given that the average value of the function is given to be u of a. The average value of the function is given to be u of a. अब बोल रहा है कि you have to which of the following four statements must be true. So u attains its maximum or not minimum on the set. So maximum है कि minimum है, यही देखना है. ठीक है, कब होगा? On the set 0 and 1 u has to attain maximum or minimum, and u here a बोल रहा है कि the function average value of the function is u of a. ठीक है, average value of the function is u of a. तो average value मतलब क्या है कि average value exactly a पे आएगा. This means u of a means average value exactly a पे आएगा. u of x का average value will be exactly at a. ठीक है, तो exactly at a in this interval a plus r and a minus r, a plus r and a minus r, in this interval a plus r and a minus r बोल रहा है कि average value is exactly at a. And when this is possible for a linear function only, if the function is linear, increasing or decreasing, only for linear function you just get the average value exactly at a. Curvature में तो नहीं होता, only for linear functions. Only at linear functions you will find the exact value at the middle. है कि नहीं? समझ पा रहा हो ना what I'm trying to say? ठीक है, तो definitely this minimum value and the maximum value will be what at the end points. यहाँ पे minimum आएगा. If the curve is increasing, then minimum value will be over here and the maximum value will be here. And if the curve is decreasing, then vice versa. Minimum value will be here and maximum value will be here. ठीक है. So what can I say from here? So u attains both its maximum and minimum on the set 0 to 1. Option D is correct. बाकी चीज तो होगा नहीं. बोल रहा है कि u attains its maximum but not minimum. Maximum, minimum, all the points will be attained because it's a linear function. Linear can be increasing, decreasing, whatever. This will attain the maximum and the minimum value on this set 0 to 1 because we are limited to 0 to 1 only. और third option क्या बोल रहा है? U attains either its maximum or its minimum. One of this. Then it must be a constant. ठीक है, तो constant तो ये तो होगा नहीं. It's either maximum or minimum on the set. ठीक है, तो U must be a linear over here. 2021. चलो आ जाओ. First question from 2021. Fx is given to be e raised to the power of mod of x minus of mod of x. G of theta is integration minus 1 to 1 f of x by theta. F of x by theta is given. अच्छा, we have to find limit theta tends to 0, g of theta divided by theta. ठीक है, माने basically we have to solve this g of theta. पहले तो g of theta निकालो. We have to evaluate this g of theta. So what is g of theta? G of theta is integration minus 1 to 1 f of x by theta. So this is basically f of e raised to the power of minus of mod of x by theta, and this is d of x. So theta is a constant. Theta तो constant है. With respect to this integral, theta is constant because integration is dependent on x. X का limit है. अच्छा, so what else we can see from here? अच्छा, एक काम कर लेते. I take this theta outside. So we are having e raised to the power of, ये थीटा है ना, so थीटा डाल भी सकते हो. नहीं तो एक काम कर लेते हैं. वन थिंग वी कैन डू फ्रॉम हियर. देखो -1 to 1 इज देयर. एक तो फीलिंग आ रहा है कि ऑड इवन वाला फंक्शन वाला प्रॉपर्टी विल बी डेफिनेटली हेल्पफुल. और ये तो क्लियरली इवन फंक्शन ही है. यस और नो? इट्स अ इवन फंक्शन. वी कैन क्लियरली सी this function is even function. So we can write this as 2 times of integration 0 to 1, which is much more easier, no? E raised to the power of minus. ये even function है. You all can check this thing. So we have e raised to the power of minus of mod of x divided by theta. अब देखो, we are taking from 0 to 1. 0 to 1 में तो mod of x will be positive only. 0 to 1 में mod of x is positive now. है कि नहीं? So can I write this as x upon mod theta? D of x will work out. So we have 2 times of integration e raised to the power of minus x divided by theta mod theta. So e raised to the power of क्या होगा? This will become e raised to the power of minus x divided by mod theta and divided by differentiation of this thing, which is -1 by mod theta. यही होता है ना? And this is 0 to 1. Range is going from 0 to 1. So 2 times of reciprocal ले लो. So minus भी आएगा, तो minus of 2 times of mod theta into e raised to the power of minus 1 by mod theta. 1 डालोगे तो 1 और फिर माइनस ऑफ e raised to the power of 0 which is 1, so minus of 1. क्लियर है? तो ये थोड़ा अगर रीराइट करके लिखा जाए तो दिस इज आई सिंप्लीफाई दिस थिंग, आई कैन राइट दिस एज 2 times of mod theta into 1 minus e raised to the power of minus 1 by mod theta. क्लियर है? minus 1 by mod theta. That is what we are having final में. ठीक है? This is your integration. This is g of theta. This is g of theta. अब बोल रहा है कि find limit theta tends to 0. Limit theta tends to 0. g of theta by theta. माने g of theta by theta माने 2 times of mod theta into 1 minus e raised to the power of minus 1 by theta mod theta. ठीक है? और फिर divided by theta. Theta by theta will not exist. As theta tends to 0, this will tend to, for all cases, as theta tends to 0, whether positive or negative. ये तो समझ पा रहे हो? Where theta tends to 0, whether positive or negative, this quantity will tend to e raised to the power of, देखो, for positive तो ये क्या हो जाएगा? E raised to the power of minus 1 by 0, which is tending to minus infinity. So this means this will tend to 0. And theta by theta cancels out. So the right hand limit will be 2. Right hand limit तो 2 आएगा. ठीक है? Because this quantity will tend to 0. So 1 minus 0, which is 1 only, and this will become theta by theta because theta is positive. But left hand limit will be, this will become e to the power of minus 1 by negative. ये negative से खोलेगा तब. Left hand limit theta negative माने 0 minus के लिए this will be negative. तो minus minus positive. तो 1 by 0, that positive 0 will tend to infinity. So e raised to the power of infinity will tend to infinity, and overall quantity will tend to infinity. So your left hand limit will be infinity. Obviously option D will be correct. This does not exist. देखो भाई next question क्या बोल रहा है? Next question, this question itself looks like a very scary one, but this is one of the easiest questions. Look at this. So px is given to be this polynomial. Fine. If not, x is basically integration 0 to x pt dt for x more than 0, and it's minus of x to 0 p of t dt when x is less than 0. Fine. So f1x is this. F1x is e raised to the power of f naught x. F2x is e raised to the power of f1x, and so on and so forth. So basically some sort of relations, a chain kind of thing is given. समझ पा रहे हो ना? A chain kind of thing is given. So basically they are asking for a chain is given. F1x is e raised to the power of f naught x. F2x is e raised to the power of f1x, and so on. Fnx is e raised to the power of fn minus 1x. बोल रहा है कि how many roots does this equation has? D of fnx divided by dx is equal to 0. How many roots this will have? So some sort of chain is given. We have to decode this chain first of all. Very simple question. देख लो भाई, पूछा क्या है? d by dx of fnx ही तो पूछा है. d by dx of fnx है ना? यही तो पूछा है. ठीक है? So d by dx of fnx will be this is basically e raised to the power of, ये क्या हो जाएगा? This will become e raised to the power of fn minus 1x. ठीक है? इसका डिफरेंशिएशन क्या होगा? e का डिफरेंशिएशन is e raised to the power of x into differentiation of fn minus 1x into differentiation of fn minus 1x, and this is equated to 0. When you equate this to 0, this cannot be 0 क्योंकि ये तो exponential function है. This cannot be 0. So you are only left out to solve this thing. So d by dx of fn minus 1x to be 0. तो खाली आपको ये solve करना है. ठीक है? मतलब क्या है कि you are proving from here you have reduced this into this. So from here you have reduced this into this. फिर से you will do the same thing. फिर से you will do the same thing and you will end up getting d by dx of, ठीक है, कुछ ना कुछ some sort of exponents will be there which won't be 0. And similarly, ये अगर fn minus 1 is, so the next term will be what? Fn minus 2x will be 0. Getting my point, what I'm trying to say? And so on. This continues. The next term is what? This will keep on decreasing. The next term will be fn minus 3 times of x will be 0, and so on. This will continue. This goes up till d by dx of f naught x. कहाँ पे जाके रुकेगा? F naught x पे जाके रुकेगा. This is decreasing, right? Fn minus 1 and so on, so on, so forth. So this is decreasing. So this will stop at f of f naught is equal to 0. d by dx of f naught x is equal to 0. मतलब ये क्या है? What is the meaning of this thing? d by dx of f naught is equal to 0. मतलब क्या है भाई? px is equal to 0. Yes or no? सोच के बोलना. px is equal to 0, हाँ या ना, क्योंकि यहाँ पे d by dx करोगे, d by dx of this thing, d by dx of f naught, तो क्या है यहाँ पे both the cases are in terms of integration. Leibniz rule से you will get p of x ना, तो वो तो p of x ही होगा. So p of x is equal to 0. और फिर p of x क्या है? p of x is basically x cube minus 3x square. ये तो simple polynomial is given. Simple polynomial is given. So this can be factorized. This is basically x. You take out x common from here. So this becomes x square minus 3x plus 2. है ना? So this is basically x into x minus 1 times of x minus 2. Simple polynomial is given. So what are the two roots over here? बोल रहा है कि how many, क्या question क्या है? How many roots does this have in this interval? How many roots does this have in this interval minus infinity to infinity? So how many roots are there? X is equal to 0, 1 and 2. So all total 3 roots are there. Acha, come down to this one. So one functional relation is given. Function is defined from R to R. It's a continuous function and f of x plus 1 is equal to half times of fx. So we have an to be this. An is integration 0 to n fx dx for all integers n greater than or equals to 1. Then basically we have to find limit n tends to infinity an. यही main funda है. ठीक है. So you know there is like I have seen lots of complicated solutions to this particular question. I have seen a lot of complicated solutions to this particular question. What I have done is I have found out a simpler solution. Simpler solution by solving this functional relation. By taking some function, I have found out a simpler solution to this thing. ठीक है, simple से जाएंगे. I won't be making a bit of more complicated kind of thing. If you see my 2021 solutions, you will see that the same question has been done by something else, some different method, which is iteration process. Iteration process method I have solved over there. ठीक है, by taking some values over there, I have tried to bring this in terms of iteration, माने process में, एक process माने एक chain में. So I have found out a very simple solution to this thing. What is this? You solve this functional relation over here by taking some values और फिर वहां से verify कर दो, बस इतना simple है. ठीक है, that will be much more easier. कि देखो ये f of x plus 1 is equal to half times of fx. ठीक है, तो for simplicity I'll consider this fx to be some constant times of r raised to the power of x. ठीक है, let us compare with this functional relation from here. Can we verify or can we compare with this thing? F of x plus 1 will be what? C times of r raised to the power of x plus 1, which is nothing but C times of r raised to the power of x into r. होगा यही चीज. ठीक है, तो C times of, can I say this is nothing but r times of C times of r raised to the power of x is nothing but fx only. मतलब what is r? R is what? R is, just compare with these two. What is r? R must be half, na? R must be half. So r is half from here. So we have the function now. So fx is C times of half raised to the power of x. ठीक है, this is my my way of hit and trial and solving this thing. It's easier, ज्यादा complicated है नहीं. It's easier, more comparatively it's much more easier. So fx is C times of half raised to the power of x. You got the function, so we can find out what is an. So an is what? Integration 0 to n fx. C times C तो constant है, तो half raised to the power of x dx. और ये हमें आता है. So basically this is what? Half raised to the power of x divided by ln half. Yes or no? And this goes from 0 to n. So C times half raised to the power of n divided by ln half. और यहाँ पे क्या आएगा? Minus of half raised to the power of 0, which is 1. तो -1. ठीक है कि नहीं? यही चीज आ रहा है. माने दिस थिंग इज कंप्लीटली, अगर देखा जाए तो C times of half raised to the power of n, I separate the constants, half raised to the power of n divided by ln half, और फिर minus of C by ln half. बोल रहा है कि what is limit n tends to infinity. So I am taking limit n tends to infinity over here. So this becomes limit n tends to infinity a will be limit n tends to infinity. This entire thing तो आपको ये नहीं लगता कि ये जीरो पे जाएगा? दिस विल टेंड टू जीरो, हाफ रेज टू द पावर ऑफ इनफाइनाइट विल टेंड टू जीरो। ठीक है, तो सी बाई लॉग हाफ तो इज जस्ट अ कांस्टेंट, तो ये कांस्टेंट है, कांस्टेंट टाइम्स ऑफ जीरो, तो ये जीरो पे जाएगा, और माइनस ऑफ ये तो कांस्टेंट ही है, तो सी बाई एल एन हाफ। सो दिस इज माइनस ऑफ सी बाई एल एन हाफ, माइनस ऑफ सी बाई एल एन हाफ इज देयर। ठीक है, दिस इज योर लिमिट, फाइनल में जाके वी आर गेटिंग दिस लिमिट। एंड नाउ वंस यू कंपेयर विद दीज ऑप्शंस, बोल रहा है कि इंटीग्रेशन देखो, इन ऑल द ऑप्शंस वी आर हैविंग 0 to 1 एफ एक्स डी एक्स। ऑप्शंस में 0 to 1 एफ एक्स डी एक्स आपको कैलकुलेट करना है। लेट अस कैलकुलेट इंटीग्रेशन 0 to 1 एफ एक्स डी एक्स समवेयर। इंटीग्रेशन 0 to 1 एफ एक्स डी एक्स, एफ एक्स बोले तो सी टाइम्स ऑफ, सी इज कांस्टेंट, बाहर कर लो, हाफ रेज टू द पावर ऑफ एक्स डी एक्स। तो सी टाइम्स ऑफ हाफ रेज टू द पावर ऑफ एक्स डिवाइडेड बाई एल एन हाफ goes from 0 to 1. तो c times of half raised to the power of 0 is 1 divided by ln half। ठीक है ना, ये हाफ आएगा, फर्स्ट हाफ आएगा, और फिर माइनस ऑफ c अपॉन हाफ रेज्ड टू द पावर ऑफ 0 इज 1, सो c अपॉन ln हाफ। तो ये कुछ तो सिमिलर आ रहा है, यहाँ पे खाली हाफ आ रहा है। ठीक है, एंड वंस यू टेक दिस वैल्यू ओवर हियर, ये देखो ये क्या आ रहा है, व्हाट इज दिस, c टाइम्स ऑफ हाफ माइनस 1। तो c टाइम्स ऑफ हाफ माइनस 1 माने c टाइम्स ऑफ हाफ माइनस 1 माने माइनस हाफ, माने माइनस हाफ, तो माइनस ऑफ c बाई 2 टाइम्स ऑफ ln हाफ, ln हाफ, ये भी माइनस, ये भी माइनस, ठीक है, और ये भी माइनस c बाई ln हाफ, एंड दिस इज माइनस ऑफ c बाई 2 टाइम्स ऑफ ln हाफ। ऑप्शन डी विल बी करेक्ट, क्लियरली दिखाई दे रहा है कि 2 टाइम्स ऑफ दिस विल बी द सेम, माइनस माइनस कैंसिल्स आउट, सो c बाई 2 टाइम्स ऑफ, c बाई 2 टाइम्स ऑफ log half will cancel out, तो क्या बचेगा, c by 2 is equal to c, which is nothing but 2c only, so 2 times of this thing will be the answer. Okay, so we move on to ISI 2020 PYQs. आ जाओ, first question. What is the first question saying? What is the limit of in the summation k is equal to 1 to n e raised to the power of minus k by n divided by n? This is a very easy question. कुछ है नहीं question में, ठीक है, very बेकार question they have given. What is this? Summation k is equal to 1 to n, ठीक है, e 1 by n times of f of r by n is there, तो r तो है नहीं, k is there, so what, k by n, so what is this, basically this is integration 0 to 1 e raised to the power of what, minus of x, k by n, r by n is replaced by x, 1 by n is replaced by dx, and summation is replaced by integration, limits goes from 0 to 1. So what is this, basically integration e raised to the power of minus x, माने e raised to the power of minus x, minus बाहर कर लो, this goes from 0 to 1, so this is e raised to the power of minus 1 minus of e raised to the power of 0 which is 1, so ये minus है, ठीक है, तो what is this basically, so 1 minus e raised to the power of minus 1, option C is correct. चलो next question. Oh, done, no more questions. 2019 question. The first question is from UGB. चलो क्या बोल रहा है question. Let f such that r to r be a twice differentiable function such that integration of x minus y to x plus y, mean value property. So 1 by 2y is given and this is equal to fx. We have to show that there exists a to b, a comma b belongs to r such that fx is equal to ax plus b. So you can use that average value वाला function logic. ठीक है, I am showing you, I'll just show you a theoretical, more theoretical proof as well, but वो भी चलेगा. You know, this is more of a similar question. This is more of a similar question to this problem which we have done. This mean value theorem wala property, this mean value theorem, the same thing is given over here, and we had concluded that over here one average value was taken over here. तो ये वही वाला same logic है, अगर ध्यान से देखोगे तो this is nothing but the average value of the function given. ठीक है, average value of the function is given to be this, मतलब ये जो है ना, integration of x minus y to x plus y and f of t, और फिर नीचे क्या है ना, 2y is basically x plus y minus of x minus y is given. ठीक है, this is given, so technically this is what the average value of the function, ये average value है, and बोल रहा है कि एवरेज वैल्यू x पे आएगा फॉर ऑल x बिलोंग्स टू r एंड ऑल y बिलोंग्स टू y मोर देन 0. सो बेसिकली द एवरेज वैल्यू विल बी एग्जैक्टली एट x. ठीक है, तो x प्लस वाई और x माइनस वाई के बीच में x पे आएगा. तो व्हाट इज दिस पॉसिबल? सो व्हेन दिस इज पॉसिबल, व्हेन fx इज लीनियर फंक्शन, तो वो लीनियर पे आएगा. ये थोड़ा आपको एक्सप्लेन करके लिखना है. सो नाउ आई एम शोइंग यू द लॉजिकल वे टू प्रूव दिस थिंग. ठीक है, थियोरेटिकल, मोर थियोरेटिकल प्रूफ ऑफ दिस थिंग. तो व्हाट आई विल डू, so basically we are having integration x minus y to x plus y, and this is basically ft dt. Ft dt is given, which is equal to, I'm writing this as, I'll cross multiply this thing for the sake of simple calculations. This is fx. So what I do, I differentiate both the sides with respect to y. Differentiating both the sides with respect to y. ठीक है, with respect to y करेंगे माने x is constant. So what will happen? So this will become x plus y, f of x plus y, and this will become plus f of x minus y by Leibniz rule, plus f of x minus y, because we are multiplying by minus y ना, मतलब minus y का differentiation which is minus 1, तो minus minus plus हो जाएगा, and this is equal to 2 times of fx. We are differentiating with respect to y. ठीक है, चलेगा. Again I differentiate this thing, so with respect to y, so this becomes f dash of x plus y minus f dash of x minus y. ये क्यों करेंगे सर? Why are we doing this thing? 2 times of fx. नहीं, ये 0 आएगा, sorry. Right hand side will be 0 because we are differentiating, again we are differentiating with respect to y. We are differentiating with respect to y. Again we are differentiating with respect to y. Why are we doing this thing? Because our target is to show that ये है ना, we have to show that fx is linear, fx is ax plus b. So what I'll try to prove is, I'll try to prove that fx is equal to, f double dash of x is equal to 0. I'll try to prove that f double dash of x is equal to 0. समझ पा रहे हो ना? f double dash of x is 0 माने what? fx is linear function. Clear है? So from there itself I'm trying to show some sort of thing like this. चलेगा? And this is equal to 0. अच्छा, so what are we proving? We are getting some relation, that is f dash of x plus y is equal to f dash of x minus y. क्या समझे? ठीक है, टारगेट ये रहना चाहिए, टारगेट मस्ट बी f dash of f double dash of x is equal to 0. this is the target actually to prove. ठीक है, so likewise here I have some cases. ये चीज ध्यान रखना है. Basically here x belongs to all real numbers and y is positive over here. So what I do, I can conclude something from here. Case 1 ले लेते. Case 1, we have x plus y and x minus y. ठीक है, I have to bring in terms of single variable. तो हम एक काम कर लेते हैं कि I'll take y as t by 2, where y is positive. ठीक है, यहाँ पे t positive है, because y is positive, t is positive. ठीक है, and x is t by 2, x is also t by 2. क्यों लेंगे भाई? Why will I take this thing? देखो लेफ्ट हैंड साइड में f dash of t आ जाएगा ना. This will become f dash of t by 2 plus f dash of t, which is f dash of t. And right hand side में we will be getting f dash of t by 2 minus t by 2, which is f dash of 0. समझ पा रहे हो ना? This is f dash of 0. So we are getting f dash of t to be a constant function. समझ पा रहे हो? We are getting f dash of t will be a constant function. अब f dash of t अगर constant है तो f double dash of t is what? 0 ना? F double dash of t is what? 0. So hence we are getting from the first case, we are getting fx to be a linear function, which implies f is linear. अब second case क्या होगा? Second case is I am taking y to be minus t by 2. Y is minus t by 2. Now minus t by 2 है तो यहाँ पे t negative लेना है. I am taking t has to be negative. समझ पा रहे हो ना? t has to be negative because y is positive, so t has to be negative. ठीक है, now I have to bring, if y is minus t by 2, somehow I have to bring t over here. So I have to take x to be t by 2. I have to take x to be t by 2. ये नहीं कि x को minus t by 2 ले लिया. I have to take x to be t by 2 because this I have to bring, ये वाला जो चीज है ना, this will bring you 0 and this will give you minus minus plus. समझ पा रहे हो ना? This will give you 0 और ये minus minus plus. माने what I'm trying to say is, you will be getting left hand side में you will be getting f of x plus y, तो ये 0 आ जाएगा, f dash of 0, and this will give you minus minus plus, माने minus t by 2 and t/2 माइनस ऑफ माइनस माइनस प्लस माने t/2 प्लस t/2 माने f ऑफ t माने वही सेम चीज आ जाएगा। समझ पा रहे हो कि नहीं? अगेन द सेम लॉजिक। सो f डबल डैश ऑफ t will be what? 0. So fx is ax plus b. Linear. Hence proof. One more theoretic way of solving this thing using calculus. We are solving this. 2018 question. See the next question. Next question is saying f such that 0 to infinity, positive domain hai, goes to R be a continuous function such that for all x belongs to 0 to infinity, f of 2x is equal to fx. We have to show that g is defined by this equation gx. This is a constant function. Very simple question. You differentiate this thing. So g dash of x is what? G dash of x. We'll show that g dash of x is equal to 0. So g dash of x will be by Leibniz rule. So we have f of 2x. ठीक है, और फिर क्या? डिवाइडेड बाय 2x into differentiation of 2x which is 2 और minus of f of x divided by x into differentiation of x which is 1. बस हो गया। तो 2 cancels out. So we are having f of 2x minus of f of x divided by x. So we have f of 2x minus f of x will be what? 0 only, because f of 2x is equal to fx. So we have 0. So which means g dash of x to be 0. Which means g of x is what? A constant function. G is a constant function. And do mention the properties, like we are using Leibniz rule here. So do take care of the properties as well. क्योंकि वहां पे properties भी था. Leibniz rule, when I have stated Leibniz rule, you must have seen over there. We have seen few properties over there which is being applicable over here for Leibniz rule. To apply Leibniz rule, कुछ properties आपको ध्यान में रखना है. तो वो statement से देख लेना और लिख लेना. ठीक है. So next we move on to ISI 2017 PYQs. चलो, first question. First question is saying the area of the region bounded by the curve y is equal to tan x, the x-axis, and the tangent to the curve y is equal to tan x at x is equal to pi by 4. So we have several things here. So we have tan x first. Area bounded का question है. So we have tan x first. तो tan x कहाँ तक चाहिए? Tan x, the x-axis, and the tangent to the curve at pi by 4. Okay, so I'm taking the tan x over here. You need this portion. ठीक है, ये तो graph of tan x है. This is pi by 2. This is pi by 2. ठीक है. अब बोल रहा है कि pi by 4 पे x axis तो बना लिया, pi by 2 बना लिया, and then tan x also I have made the x axis and the tangent to the curve at tan x. So we have a tangent to this curve. We have a tangent to this curve. We have a tangent like this. ठीक है. At x is equal to pi by 4, we have a tangent. ठीक है. तो आपसे पूछा गया है कि what is the area of the region bounded by this curve? माने what is the area of this region? What is the area of this region? ठीक है. Question is pretty simple. So what we can do? तो एक तो हमें यहाँ से one thing clearly we can see. Let's find out the slope of this tangent. देखो x is equal to pi by 4 पे चाहिए ना. ये तो y is equal to tan x है. This is y is equal to tan x. ठीक है. तो what I can do is at x is equal to pi by 4. ये कौन सा point है? This point is basically pi by 4 पे क्या आएगा? 1. मतलब this point is basically pi by 4 comma 1. This point is pi by 4 comma 1. ठीक है. So what I can do, let us find the slope of this curve. Slope of this curve is dy by dx. Slope of this curve at this particular point है ना. तो slope क्या होगा? sec square x. ठीक है. And slope of this curve मतलब y dash at this point. ठीक है. This point at p मान लो, suppose this point p. तो y dash p will be sec square pi by 4 only. ठीक है. sec square pi by 4 which is 2. चलेगा. This is 2. तो ये क्या है? Slope of the tangent at the point p. So if this is slope of tangent at point p, मतलब can I call this as tan theta? Meaning of slope is what? Tan theta only. मतलब ये थीटा है आज के दिन. ये थीटा है. यही तो है ना tangent. Tangent का थीटा is this. है ना? So tan theta is equal to 2. This is what we have figured out. ठीक है. ये हाइट 1 है. ये हाइट 1 है. ठीक है. So tan theta is 2 माने 2/1, ठीक है, ये हाइट हमें मालूम है ये 1 है, तो डेफिनेटली इतना आपको क्लियर हो गया होगा कि दिस इज एक्चुअली हाफ, दिस मस्ट बी हाफ, है कि नहीं? तभी ना जाके tan थीटा 2 आएगा। यस और नो? क्लियर है? दिस इज एक्चुअली हाफ। सो व्हाट आई कैन से फ्रॉम हियर, what I can say from here, we need to find the area of this region, this shaded region. So can I do one thing? Can I just calculate this total area and then subtract this triangle ka area? So we are done. है कि नहीं? So we have required area will be required area. This will be what? Integration 0 to pi by 4. 0 to pi by 4 tan x, which is the area under this curve. 0 to pi by 4 tan x dx minus the area of this triangle, half into base into height. So half into base बोलो तो half into height. Easy question. Yes. तो tan x का इंटीग्रेशन इज log of sec x, log of sec x minus ca1/4, ठीक है, log of sec x and this range goes from 0 to pi by 4. तो log of sec pi by 4 मतलब this will become sec 0 is 1, ठीक है, तो this will become log of root 2, log of root 2 minus 1/4, log of root 2 minus 1/4, ठीक है. So what we can do, we can take out one half common from here, एक हाफ यहां से बाहर आ जाएगा, so this will become ln 2 ln 2 minus of this will become half times of log 2 minus half है क्या, half times of log 2 minus half. Option C is correct. Let f and g be two real valued functions, continuous functions defined on this closed interval AB such that f of a is less than g of a and f of b is greater than g of b. So you have to take the figure in such a way, okay, such that these conditions are maintained. Then the area enclosed between the graphs of these two functions and the lines x is equal to a and x is equal to b is always given by what? ठीक है, तो there are certain conditions which needs to be followed. तो roughly एक ग्राफ बना लेंगे. So here we are having f of a. The first thing is saying f of a must be less than g of a, and the second one is saying f of b is less than g of b. So you all consider two graphs. So you will consider two graphs. One is f a and g of a. ठीक है, दो ग्राफ्स ऐसे ड्रॉ कर लो, ठीक है, such that these conditions are maintained. Such that these conditions are maintained. अब कौन सा कैसे लिया जाए? Which one to take? Which one to take as f and which one to take as g? F of a must be less than g of a. ठीक है, तो somewhere over here a और a को मान लेते, ठीक है, somewhere over here I am taking a and somewhere over here I am taking b. x is equal to a and x is equal to b. तो बोल रहा है कि f of a तो f of a is lower, तो यहाँ पे f of a is lower, तो लोअर वाला कर्व को f मान लेते हैं. लोअर वाला कर्व इज f, माने रेड वाला कर्व इज f and black wala curve is g. Black wala curve is g. So here on this side I have taken f of a. On this side I have taken f of a is less than g of a, and on this side I have taken g of a. F of b is greater than g of b. F of b is greater than g of b, which you can see from the diagram itself. अब बोल रहा है कि what is the area enclosed between them? So you have to figure out this area. You have to figure out this area, and the rest is easy to calculate, which is just simple integration. So what is it basically? Upper curve minus lower curve. वही तो करते हो. That's what you do for area under the curve, है ना? What do you do? Upper curve minus lower curve. So let's say this is some point. ये कुछ point मान लो, suppose C point है. So we are having upper curve. First region में क्या है? First region में we are having A to C, A to C. फिर second region में C to B. तो first region में what are we having? Upper curve is F minus G dx or whatever. ठीक है, function of x to dx. तो and then C to B. So second region में क्या है? C to B, upper curve minus lower curve. So F minus G. ठीक है ना, एक सेकेंड. दिस इज बेसिकली ये G था, सॉरी, दिस विल बी G minus F. आई एम सॉरी, ये g था, this is g and this is f, so g minus f. अच्छा, ये g था, ये f था, so this will be g minus f, g minus f dx, upper curve minus lower curve, and here for the second one we are having upper curve minus lower curve, which is f minus g dx. चलेगा? That's what we are having. This is the area under the curve. अब ये तो दिखाई दे रहा है कि we are taking from a to c and then c to b, and here we are having g minus f and f minus g. मतलब clearly we can write this as integration. अब आपको तो ये clearly दिखाई दे रहा है कि either this can be negative, this region can be negative, or this can be positive, or vice versa. ठीक है, ऐसा एक कॉन्फ़िगरेशन लिया जा सकता है. So I can combine these two and write this as what are we doing? Just simply taking a minus sign common and then we are solving. माने इस रीजन में नेगेटिव है, इस रीजन में पॉजिटिव है. So what I can say from here is integration a to b mod of fx minus gx. यही तो है, mod of f minus g dx. We are just simply writing this thing, and this mod of f minus g will actually combine this positive sign as well as the negative sign. ठीक है, so a to c में this is g minus f and c to b में as per this diagram we have taken f minus g. उल्टा भी हो सकता है, but this is what we are taking, you know, we have taken this configuration, and यहाँ पे both these signs are getting combined over here. Both these signs are getting combined over here. So option A will be correct. ये clearly this was an easy problem. You just need to draw the graph easily. ठीक ठाक से ग्राफ ड्रॉ कर लोगे, so we are done. देखो भाई, नेक्स्ट क्वेश्चन क्या बोल रहा है कि लेट f such that 0 to 2 belongs goes to R be a continuous function such that this condition is given, then which of the following statements must be true? So either f must be increasing, strictly increasing, मतलब क्या चेक करना है? Basically we have to comment on f, whether f is having some maximum value, minimum value, or f is strictly increasing or decreasing. That's what we need to check from here. So we have some condition given, integration of 0 to 2 fx dx, and this is less than f of 2. So ये continuous function है. What I do over here, increasing, decreasing, यही check करना है ना बस. Basically what I am doing is I am defining a new function over here with respect to this fx. ठीक है, mean value property. Yes, yes, I am defining a new function over here, g of t. I am defining a new function g of t, which is integration 0 to 2, 0 to t, ठीक है, 0 to t fx dx. I am defining a new function, integration 0 to t, g of t will be integration 0 to t fx dx, where t belongs to 0 to 2. T comes from 0 to 2. ठीक है, why will I do this thing? Because our target will be to use this Lagrange's mean value theorem by LMVT. We can say for t belongs to 0 to 2, close 0 to 2, we can say there exists some c. There exists some c which belongs to open 0 to 2 such that g dash of c will be how much? G dash of c will be equal to g of 2 minus of g of 0 divided by 2 minus 0. Yes or no? By Lagrange's mean value theorem, we can say this thing. For some t belongs to close 0 to 2, we are getting some, there exists some c, belongs to open 0 to 2 such that g dash of c will be g of 2 minus g of 0 divided by 2 minus 0. ठीक है, तो c belongs to 0 to 2, c belongs to 0 to 2, we are getting this relation from here. So what is g dash of c from here? ये देख लेते हैं, what is g dash of c? From this relation we can find out what is g dash of c. So g dash of t will be, you differentiate both the sides. So by Leibniz rule, we are having this will be f of t. Right hand side, this will be f of t. So g dash of c will be how much? G dash of c will be f of c only. G dash of c will be f of c. तो यहाँ पे ये जो चीज है, this is f of c only. So we are getting some c belongs to 0 to 2 such that ये जो f of c है, f of c, we are getting in the place of g dash of c, there exists some c belongs to 0 to 2. We are saying for which f of c is equal to g of 2. G of 2 is what? G of 2 is basically integration 0 to 2 fx dx minus g of 0. Or what is g of 0 from here? 0 only, divided by 2. ठीक है ना? So what are we getting from here finally? So we are getting f of c will be, f of c आएगा क्या? Integration 0 to 2 fx dx divided by 2. ठीक है, और यही जो चीज है, दिस थिंग इज गिवन इन द क्वेश्चन टू बी लेस देन एफ ऑफ टू. Absolutely. Ha. F of C is less than F of 2 for some C. So we are getting something like this. We are getting there exists some C, there exists some C for which this condition is satisfied. जो condition question में दिया गया है. There exists some C for which this condition is getting satisfied. ठीक है, मतलब clearly क्या हो रहा है कि this cuts, मतलब there exists some C, मतलब some C क्या है, वो C such that F of C is this condition is getting satisfied, मतलब कुछ ना कुछ वैल्यू है. हाँ, तो मतलब क्या है कि 2 पे ये मिनिमम दे नहीं सकता. एफ कैनॉट गिव मिनिमम एट एक्स इज इक्वल टू 2. ठीक है, सो एफ कैनॉट हैव मिनिमम एट एक्स इज इक्वल टू 2. ऑप्शन सी मस्ट बी करेक्ट. चलो नेक्स्ट वन. ओके, सो नेक्स्ट वी मूव ऑन टू 2016 PYQs. आ जाओ. फर्स्ट क्वेश्चन. First question is integration of 1 to n box of x whole to the power of x minus box x is given. So we have to evaluate this integral. This is easy. This is basically all these are what integer points. So we are having greatest integer. So this will break at what integer points. So what we can do, we can write this integral as integration 0 to 1 से start हो रहा है. So 1 to 2. ठीक है. And then what 2 to 3 and so on. This will continue. Then 3 to 4 and so on. ये कहां तक जाएगा? This will go up till n-1 to n. समझ पा रहे हो ना? That's how we do the questions basically of greatest integer functions, which involves integration. अब क्या है कि भाई, so here 1 in between 1 and 2 box of x क्या होता है? 1. Box of x is what? 1. So 1 raised to the power of x minus 1, which is 1 only. So 1 dx. ठीक है. And then 2 to 3 में we are getting 2. 2 to 3 में box of x is what? 2. So 2 raised to the power of x minus 2 dx and so on. Next is what? 3 raised to the power of x minus 3 dx and so on. अच्छा, लास्ट तक जाएगा. लास्ट इज व्हाट? लास्ट विल बी n-1. बॉक्स ऑफ x इज व्हाट? n-1 raised to the power of x minus this will become n-1. Yes or no? dx. Next, so we have to just solve this. So we are getting 1 plus first वाला तो 1 है. 1 dx 1 x only. ठीक है, which is 2 minus 1, which is 1. So 1 plus this is 2 raised to the power of x minus 2 divided by ln 2. Range goes from 2 to 3. Then 3 raised to the power of x minus 3 divided by ln x minus 3. Sorry, ln 3. Range goes from 3 to 4. कहां तक जाएगा? This will become n-1. n-1 raised to the power of x minus n-1 divided by ln n-1. The range goes from n-1 to n. ठीक है. So next is what? 1 plus. अब ये वैल्यूज डाल दो, अभी तो हो ही गया क्वेश्चन. So this is basically what? This is 3 minus 2, which is 2. And 2 minus वो 0 आएगा. 2 minus 1, which is 1 by log 2. 1 by ln 2. Plus फिर यहाँ पे 4 डालो तो 4 minus 3 again. 4 minus 3 1. 3 minus और फिर 3 minus 3 0. So 3 minus 1, which is 2. So 2 by log 3. ठीक है. फिर नेक्स्ट टर्म क्या होगा? 3 by log 4 and so on continues. और लास्ट तक जाएगा. लास्ट विल बी n-1. यहाँ पे क्या है? n माइनस माने n-1. ठीक है, और फिर -1 माने n-2. तो n-2 तक जाएगा ये. n-2. Am I correct? n-2 divided by ln n-1. हाँ या ना? So this is option B is correct. देखो भाई 19th वन क्या बोल रहा है? So let f such that R to R be a differentiable and strictly decreasing function such that f of 0 is 1 and f of 1 is 0 for x belongs to R. So we have capital of fx given to be this function. So what you have to comment? Again, you have to comment on whether f is strictly increasing, nahi to f is strictly decreasing, maximum, minimum, whatever you need to solve. Yes, derivative. Simple thing is derivative. What else we'll do? Now f is here, small f is what? Decreasing function. ये चीज ध्यान रखना, स्मॉल एफ इज डिक्रीजिंग फंक्शन सच अ वे सच दैट एफ ऑफ जीरो इज वन। तो हल्का सा स्केच एक बना लेते हैं। सो बेसिकली दिस इज एफ ऑफ जीरो इज वन। ठीक है, ये जीरो है, जीरो पे वन देगा। एफ ऑफ जीरो इज वन एंड एफ एफ वन इज इक्वल टू जीरो। ठीक है, हियर एफ वन इज इक्वल टू जीरो बीइंग दिस इज वन ऑफ द रूट। ठीक है, so once you differentiate this thing f dash of x, you have to comment on this capital of f. So once you differentiate this thing, this will become x minus 2 times of f of x minus 2 times of f of x. ठीक है, and you simply equate this to 0, तो you will get the critical points from here. So यहाँ से एक पॉइंट आएगा which is 2, यहाँ से एक पॉइंट आएगा 2, और ये कब जीरो हो रहा है? ये जीरो हो रहा है 1 पे। This is becoming 0 at 1, right? So you plot this on the number line, so the turning points are 1 and 2. ठीक है, so when x is more than 2, it's negative. This is what? Positive. This is positive, but this is negative. This is negative. ये देख लो, ये more than 1 पे ही नेगेटिव जा रहा है ना? तो positive times of negative will be negative, and then simply keep on changing this sign. So we have negative, positive, and negative. So clearly here we are having negative to positive, negative to positive, मतलब ये डिक्रीजिंग से इंक्रीजिंग जा रहा है, मतलब क्लियरली यहाँ पे क्या आएगा? मिनिमा आएगा। हियर वी विल बी हैविंग लोकल मिनिमा। ठीक है, एंड सिमिलरली दिस इज इंक्रीजिंग टू डिक्रीजिंग, मतलब क्या आएगा? लोकल मैक्सिमा। हाँ, तो लोकल मिनिमा एंड वन लोकल मिनिमा एंड वन लोकल मैक्सिमा वी आर गेटिंग। ठीक है, so in this interval, yes, option D is correct. So f has a unique maxima and a unique minima in this interval 0 and 3. अच्छा, ये वाला देखो, दिस यू रिमेंबर दिस क्वेश्चन एज अ रिजल्ट फॉर द टाइम बिंग। देखो, दिस f is a continuous strictly increasing function from 0 to infinity onto this thing, so it's an onto function first of all। ठीक है, onto function है, and g is equal to f inverse, so let a be greater than 0, that will be always in general, that is always greater than or equal to ab। ठीक है, वो इक्वल टू ए बी कब होगा? व्हेन एफ ऑफ ए विल बी एफ ऑफ बी एंड एफ ऑफ जीरो विल बी जीरो। दीज फंक्शंस वैल्यू आर मेंशन्ड। ये एफ ऑफ बी होगा, एफ ऑफ ए होगा, सॉरी, एंड दिस विल बी एफ ऑफ जीरो। ठीक है, देन ओनली वी कैन से इट इज ए टाइम्स ऑफ एफ ऑफ ए माइनस बी टाइम्स ऑफ बी ऑफ बी, एफ ऑफ बी। ठीक है, ऐसा यूजीबी क्वेश्चन देखो, f is a differentiable function such that f of fx is equal to x, where x belongs to 0 to 1. And also we have some condition f of 0 is equal to 1. So we have to find the value of integral of 0 to 1 x minus fx whole to the power of 2016. Okay. So we start by taking some sort of substitution over here, that we are having f of fx is equal to t. Okay. F of fx is equal to x, sorry. F of fx is given, f of fx is equal to x given. तो क्या ले? We have to solve this integral 0 to 1 x minus fx. So better I take x to be ft. If I take x as ft, then dx will be what? Dx will be f dash of t dt. F dash of t dt. Now we change the range of this, so x and t. So when x is 0, what will happen? And when x is 1, what will happen? So when x is 0, this will be f of 0, and f of 0 is 1. ठीक है, and when x is 1, when x is 1, when x is 1, this will be f of 0, मतलब t will be 0 in such case। ठीक है, q होगा, q 0 होगा। you all can figure out from here itself कि ये जो चीज है, this is fx, fx जो आएगा, fx क्या आएगा? fx will be f of t, है ना? Taking f on both the sides, f of t, and f of t is nothing but t only। f of t is nothing but from this relation will be t only, है कि नहीं? So fx, if x is 1, तो f of 1 will be 0। ठीक है, उल्टा vice versa, if x is 1, then t will be 0। ठीक है, हाँ वही 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 किया बेसिकली, f of 0 You can figure out from here. And basically what I'm trying to say, ये हटा दो. You can try to figure out from here itself, from this relation itself, you can see ये जो है f of 0 is equal to 0. So we are getting f of 1 is equal to 0. Simple thing. F of 1 is equal to 0. ठीक है. So what are we getting from here? So we have the new range from 1 to 0. 1 to 0, x minus fx. So x minus x is now ft. So ft minus of fx. Acha, fx is what? Fx was, you take f on both the sides. Fx was f of t. F of t. And what is f of t? This is t only. So fx is nothing but t only. So ft minus of t. ठीक है, ft minus of t. ft minus t whole to the power of 2016 and dx बोलो तो f dash of t dt. F dash of t dt. ठीक है. Now to adjust this range, what we can do, just to make it familiar with this relation, what we can do, we can take a minus sign common. So you take out a minus sign over here common. So this still remains to be integral 0 to 1, sorry, 1 to 0. And this becomes t minus ft. T minus ft whole to the power of 2016 times of f dash of t dt. Because this is even power, so whether t minus ft karo ki ft minus t, both have the same meaning. So now to balance this range, ठीक है, ये 1 to 0 है, but we need 0 to 1. So to balance this range, we just bring one minus sign in front and this becomes 0 to 1, t minus ft dt. T minus ft whole to the power of 2016 times of f dash of t dt. Next, what I do, I convert this in terms of x. So this becomes 0 to 1, x minus fx whole raised to the power of 2016 times of f dash of x. Why do we do this? Because we have the relation in terms of x only. So मान लो suppose ये a है. Suppose this relation is given to be a. ठीक है, और ये b है suppose. So what I do, I simply add these two. a plus b कर दो. I simply add these two. So this becomes left hand side, suppose ये कुछ I वगैरह कुछ मान लेते. Let's say this is I and this is also I. So we are dealing with I only. So I plus I will give you 2I. Left hand side is 2I and right hand side is basically integral of 0 to 1. Integral of 0 to 1. ठीक है, ये minus sign है तो क्या हुआ? Minus sign can be adjusted over here. So integral of 0 to 1. So once you add these two, x minus fx whole to the power of 2016 is getting common from here. ठीक है, ये कॉमन लेके बाकी ऐड कर दो. सो वी आर गेटिंग माइनस, यहाँ पे 1 है. ठीक है, यहाँ पे 1 है. सो 1 माइनस एफ डैश ऑफ एक्स. सो 1 माइनस एफ डैश ऑफ एक्स इंटू dx. 1 माइनस एफ डैश ऑफ एक्स इंटू dx. क्लियर है? दैट्स व्हाट वी आर गेटिंग फाइनल में जाके. 1 minus f dash of x into dx. So next I can clearly see x minus fx is having its derivative over here. You take x minus fx to be t. दिखाई दे रहा है ना? Yes or no? x minus fx to be t. x minus fx को t ले लो. So this will become 1 minus f dash of x. dx will be dt. dx will be dt. ठीक है? 1 minus f dash of x dx will be dt, and we change the range as well. So x and t. So when x is 0, and what happens when x is 1? So when x is 0, this will become 1 minus, sorry, 0 minus f of 0. F of 0 is 1. F of 0 is 1. So we have 0 minus 1, मतलब ये minus 1 हो जाएगा. And this is basically 1. So 1 minus f of 1. What is f of 1? F of 1 is 0. So 1 minus of 0, which is 1 only. So your new integral range will be from minus 1 to 1. This will be from minus 1 to 1. X minus fx को हमने t लिया है. So t raised to the power of 2016. And this dx is dt. So this is dt. ठीक है? So how much is this? Final में जाके we are getting t raised to the power of 2017. 2017 divided by 2017. Range goes from minus 1 to 1. So this is actually 2000 and you all can change this to 0 to 1 as well, क्योंकि ये even function है. This is even function. T raised to the power of 2016 is even function. So you all can bring one 2 in front and then then take the range from 0 to 2 as well. वो भी चलेगा. But directly I am solving. So this is basically 1 raised to the power of 2017, which is 1 by 2017. 1 by 2017 multiplied by देखो ये क्या बनेगा, 1 raised to the power of 2017 विच इज 1 ओनली, ठीक है, और 1 माइनस 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 प्लस हो जाएगा, सो +1, तो विच इज 2/2017, 2/2017, सो 2i इज इक्वल टू 2/2017, 2i इज इक्वल टू, ये 2i है, आई नहीं है, 2i इज इक्वल टू, यहां पे कर लेते हैं, 2i इज बेसिकली 2/2017, 2 cancels out, what is I is 1/2017, क्या आपको ये क्लियर हुआ? So what is I is 1/2017. So we move on to 2015 PYQs. आ जाओ, फर्स्ट क्वेश्चन, fx is mod of sin x divided by x if x is not equal to 0, 1 if x is equal to 0, we have to find integral of -1 to 1 fx dx, we have to solve, ठीक है, we have to find the value of integral of -1 to 1 fx dx. You can see from here that we can calculate from integral of -1 to 1 fx dx. अगर कैलकुलेशन करके भी देखना है, so you have to break like this, integration of -1 to 0 and then further from 0 to 1. In that sense you have to break, ठीक है, -1 to 0 में this will be what, minus of sin x divided by x dx, and 0 to 1 में this will be sin of x divided by x dx, sin of x divided by x dx, ठीक है. Now here we are having 0 to 1 and then -1 to 0. So do we need to integrate one of them? No. So what I'll do is I'll take x as minus t. For this particular integral, I'm taking x as minus t. Why will I take x as minus t? You will see that this will become your range. First of all, your range will become, let's say this is x and t. When x is -1, this will be 1. And when x is 0, this will be still 0. And dx is what? Minus of dt. ठीक है, तो यहाँ पे योर न्यू रेंज विल बी फ्रॉम 1 to 0, और यहाँ पे एक माइनस dt आ जाएगा, ठीक है, एंड दिस विल बिकम माइनस ऑफ साइन ऑफ माइनस टी डिवाइडेड बाय माइनस टी, ठीक है, तो दिस माइनस एंड दिस माइनस विल कैंसिल आउट, ये साइन ऑफ माइनस टी का टी, साइन ऑफ माइनस टी, दिस माइनस साइन विल कम आउट, साइन ऑफ माइनस थीटा इज माइनस साइन थीटा, सो माइनस साइन थीटा का माइनस बाहर आएगा, एंड दिस माइनस विल गेट बैलेंस्ड, तो फाइनल में जाके इंटीग्रल ऑफ 1 to 0 साइन ऑफ टी बाई टी, फाइनल में जाके इंटीग्रल ऑफ साइन 1 to 0 साइन ऑफ टी बाई टी dt, ठीक है, this minus and this minus will come out and get balanced and you are left out with this thing only, ठीक है, and which is the same as minus of 0 to 1, ये 1 to 0 ये रेंज को चेंज करोगे, माइनस साइन विल कम आउट, so sin of t divided by t dt. So now you can clearly see that we are getting this to be minus of integration of 0 to 1 sin of t divided by t dt. So this term and this term will get cancelled, क्योंकि ये देखो we are getting t over here, so this is the same thing as, you know, integration of 0 to 1 sin of x. You change the variable, which is you know, quite a common thing in integration. You can change the variable, t bolo ki x bolo, whatever you are calling. So this becomes sin of x divided by x, and this similarly this and this term will get cancelled. So answer will be 0 from your option D is correct. Chalo, next problem. So next we are having gx. Gx is given to be integral of minus x cube to x cube. So gx is given to be integral minus of x cube to x cube f of t dt. Fine. Where x is any real number and f is a continuous function such that f of t is greater than 1 for all real t. Okay. So then we have to comment on g dash of 0 is 0 and g has a local maxima. This has a unique solution. There exists a real number c such that g of x is so whatever. So basically what the first thing is, we need to differentiation, no other option, because we need to check for local maxima, local minima. So definitely you have to differentiate this thing. So we have g dash of x will be f of x cube times of 3x square and minus f of minus x cube times of minus of 3x square. So minus minus plus, so 3x square, ठीक है, तो यहां से 3x square is getting common, और फाइनल में जाके we are getting f of x cube plus f of minus of x cube, ठीक है, f of x cube plus minus of x cube, चलेगा. 3x square times of f of x cube plus f of minus x cube. Acha. So this is, what is this saying? Now ft is always greater than 1 for all real t. So whatever the function is, your ft is always greater than 1. ठीक है? For all any real value of t, ft is always positive. मतलब ये तो positive है ही. ठीक है? And 3x square is also positive, which means your this quantity is entire quantity is definitely greater than or equal to 0. क्योंकि ये क्या है कि we are proving that we are proving that g of x is increasing function. G of x is increasing function. ठीक है? We are proving g of x is increasing function. तो अगर increasing function होता है, ठीक है, तो one thing तो we can clearly say, देखो increasing function में if you see over here for increasing function as x tends to infinity, ठीक है, as x tends to infinity, ये चीज देखना, for increasing function as x tends to infinity, g of ये जो आएगा ना, ये this will become minus infinity to plus infinity f of t dt. ठीक है, this integral will also tend towards infinity. This will give you some large value, and this will give you some positive value. This will give you positive value. और नेगेटिव के लिए मान लो सपोज ये अगर पॉजिटिव होता है तो this will be negative. See, as x tends to minus infinity, this integral will go from infinity to minus infinity, ft dt. If this is positive, then this definitely has to be negative. ये पॉजिटिव देगा, ये नेगेटिव देगा. मतलब कि basically what I'm trying to say is your g function is increasing rapidly like this. ठीक है, नेगेटिव के लिए नेगेटिव and positive के लिए positive, and then definitely this will cut y is equal to c at once. Once you draw the line y is equal to c, you take the line y is equal to c, then definitely this will have some solution over here. This will cut this y is equal to c over here. At least one c. So technically this will cut at all these y is equal to c of this type. So this will definitely cut at least once. So like this much is clear to us कि there exists some real number c such that g of x is equal to c, and there is a unique solution for all c's. ठीक है, so for any real number c, this equation gx is equal to c has some real solution, has unique solution. So option B must be correct. So we have this question which says that what is the value of this following integral? Integration of 1 by 2014 to 2014 tan inverse of x by x. These are very common type of questions. ठीक है, whenever you are seeing reciprocal limits are there, the limits are reciprocal. ठीक है, एक अगर 1x है तो दूसरा 1 by x है. Whenever you are seeing reciprocal limits are there, always you take the substitution x is equal to 1 by t and then solve. Always, whenever you are saying something like this, ठीक है, something like 1 by 2000 half to 2, ठीक है, या फिर मान लो suppose 1 by 2025, you are giving in 2025, so let's say 1 by 2025 to 2025, something like this will be given. So always take x is equal to 1 by t and then solve. These are formats which are taught in definite integration. So x is equal to 1 by t. So dx is what? Dx is basically minus of 1 by t square dt. ठीक है? And your new range will be from when x is 2014, this will be 1 by 2014. And when x is 1 by 2014, this will be 2014. So your new range will also interchange and will become 2001 by 2014. New range will be what? Oh, sorry. मैंने उल्टा शायद लिख दिया. This is उल्टा होगा basically. So your new range will be from integration 2014 to 1 by 2014. 2014 to यहाँ से यहाँ तक. So 2014 to 1 by 2014. So tan inverse, this will become tan inverse 1 by t, ठीक है, and divided by x बोलो तो 1 by t, और फिर into dx बोलो तो minus 1 by t square dt. This is what we are having. तो ये फाइनल में जाके आपको ये चीज दिखाई दे रहा है कि यहाँ पे 1t, so this t and this one of this t will cancel out. So we are finally left out with what is this? Cot inverse of t. So 2014 to 1 by 2014. This is basically cot inverse t. This is cot inverse t divided by t dt. Cot inverse t divided by t dt. And this is, this is again, you can simplify and write this as, you can just adjust this. मतलब आपको तो ये मिल गया. So we can write this as 2014 to 1 by 2014. यहाँ पे एक माइनस साइन भी था. This was minus. यहाँ पे एक माइनस था. So 2014 to 1 by 2014. ठीक है. And cot inverse of x, which is the same as cot inverse of x divided by x. Both have the same meaning. I'm just changing the variable over here. ठीक है. And this, now to make the range same, what you can do, you can just adjust this minus sign over here and write this as 1 by 2014 to 2014 cot inverse of x divided by x dx. तो ठीक है. तो इसको कुछ i वगैरह मान लो. This is i, let's say. So you are simplifying i. So simply add these two i's, 1 and 2. 1 and 2 को add कर दो. So we are done. Add 1 and 2. So we will getting 2i. 2i is equal to integration 1 by 2014 till 2014, and this is basically tan inverse x plus cot inverse of x, which is pi by 2, and divided by नीचे तो x ही है भाई, dx है कि नहीं. तो pi by 2 बाहर आ गया, and we are having 1 by x, and 1 by x का integration is ln x. ठीक है. This goes from 1 by 2014 till 2014. ठीक है. तो pi by 2 times of ln 2014 minus ln 1 by 2014. This is what we are having. So ln 1 by 2014 माने this is minus minus plus हो जाएगा. So this is 2 times of, मतलब ये हो जाएगा फाइनल में, ये हो जाएगा ln 2014 माइनस ये क्या हो जाएगा ना, log 1 डिवाइडेड, log 1 माने ln 2014 होल टू द पावर ऑफ -1. तो -1 नीचे आ जाएगा तो माइनस माइनस प्लस हो जाएगा. मीन्स 2 times of ln 2, 2 times of ln 2014. So which is pi by 2 ln 2014 का होल स्क्वायर. दिस इज pi by 2 ln 2014 का होल स्क्वायर. ठीक है. pi by 2 ln 2014 का होल स्क्वायर. Oh, I think this is, you need not simplify so much of things. तो ये तो कैंसिल आउट हो रहा है यहाँ से डायरेक्टली. So we are getting pi 2 and 2 cancels out. 2 and 2 cancels out. So we are getting pi times of ln 2014. So 2i is this thing. So I is what? I is pi by 2 times of ln 2014. I is pi by 2 times of ln 2014, which is option B. Okay, so next we have this question which says if f such that 0 to infinity, domain positive, we are non-decreasing continuous function, so the function is increasing. So show that then this inequality is holding. You have to show that this inequality holds. ठीक है. अच्छा, तो by looking at the structure, you can get the feeling of this average value of the function. ध्यान से देखना. So here x, y, and z are basically positive. So by looking at the structure of this question, you can try to figure out that this is a question of average value. ठीक है ना. तो what I'm doing is I'm taking a graph over here. एक चीज ध्यान से देखना, बेसिकली एवरेज वैल्यू है ना यहाँ पे, एवरेज वैल्यू सच दैट आई एम टेकिंग अ इंक्रीजिंग फंक्शन का ग्राफ ओवर हियर and I'm dividing this graph in terms of interval x, y, and z, x, y, and z, such that x, y, z are equivalently, means equally placed. ठीक है. Such that x, y, and z are equally placed. मतलब the distance are the same. That's why I'm placing it. ठीक है. ये फंक्शन है, f का फंक्शन, f का ग्राफ f taken. So one thing you can clearly see from here, the average value in this interval x, z, the average value, ये जो average value आएगा in this interval x, z, वो क्या आएगा? That will be integration of x to z, integration x to z, f of क्या ले, f of something else, some different variable, f of u du, let's say, divided by z minus x, यही तो होता है average value in this interval. And similarly the average value in this interval yz, average value in this interval yz will be what? Y to z, y to z, and f of u du, f of u du divided by क्या? z minus u, z minus y. ठीक है, चलेगा. So now this is an increasing function, this is an increasing function. तो अगर ये अगर देखा जाए, these intervals are placed at equal distances. मतलब what I can say from here, the average value, the average value, the average value in this interval x z, ठीक है, is basically the average value of this plus average value of this divided by 2. ठीक है, the average value xz will be average value of this xy, this interval plus this interval divided by 2 will give you the average value of xz. ठीक है, and also for obvious reasons, because this is increasing function, average value of xz will be comparatively lesser than the average value of yz. Average value of xz will be comparatively lesser than average value of yz क्योंकि increasing function है. So next, rest is what? Rest is you just need to solve this thing. अगर ये होता है, average value of xz is less than or equal to average value of yz, so what I can say from here, integration of z to x, this quantity is what? This quantity x to z, f of u du divided by z minus x is less than or equal to integration y to z f of u du divided by z minus y, and both them being positive. Rest is what? Rest is you can simply integrate, just cross multiply, so this becomes z minus y times of integration of x to z f of u du. ठीक है, and this is less than or equal to z minus x times of integration y to z f of u du. ठीक है,